Please join me in welcoming our CTO, Mr. Haja Mohideen. Hi, sir. Can you hear me?
Hey Aditya, how's it going, man?
All good, sir. How's it? How are things over there?
Yeah, I'm just excited to see all these speakers, present amazing knowledge. Um, I'm proud to be part of the professionals. So when it comes to me, I'm not the professional. I'm Mickey Mouse compared to some of the speakers there. Oh my God, breathtaking! And you're doing a
I
great job.
I think everyone's very excited to listen to your workshop as well. So we have Mr. Haja who's going to be taking us through the basics of blockchain technology. He's going to make it very fun and easy to understand the entire concept of blockchain technology and how uh, I would say cryptocurrency and coins are built on the blockchain. So with that, over to you, Mr. Haja. We are very excited for your workshop.
Right, right. Hold on, just hold on, guys. Okay, here you go. So I'll be talking about blockchain and cryptocurrency. Why is this is an important subject, which is making tons of noise lately? Is because of Bitcoin. 2 months back, Bitcoin was $10,000. So now I was programming the nodes for our own Rosecoin currency, and I was looking at Bitcoin. It's going to go down to it came to 9,000. Now I'm like, holy cow! It's like $34,000, and I just going to climb up to $400,000. I was like, every bank and every private equity is buying Bitcoin like crazy, and now I think Esther is the Secretary of Finance in the US, and she's stepping inside and says she's going to regulate Bitcoin to make sure that you play by the same rules by revealing identity and so on. So I'm going to talk about the blockchain technology with the theory as well as some of the labs, right? So I'll try to finish in 2 hours with the Ethereum smart contracts and IBM's blockchain, smart ledger. And,
Sir, you have 2.5 hours. Don't worry.
yeah. Okay. All right. So I'll take it so easy. So I'm going to cover a lecture and the labs. Okay. So this is part of the RCC class. All right. If you're thinking of attending a blockchain training, forget about it. This is the training you're going to get. All right. This is the exact training you will get when you attend an RCC class. This is one of the modules. So I'm presenting the modules for the Reinvent students. Right. So what is blockchain? So blockchain was invented by a guy called Satoshi Nakamoto back in 2009. So he published a white paper called peer-to-peer cryptocurrency. Nobody know who he is. He published the paper in pseudocode, released the source code and the application as well. So now a lot of people are claiming I'm Satoshi Nakamoto and so on. Okay, there's one guy called Craig Wright. So he's trying to make a claim out of it. And the point is, Satoshi Nakamoto, back in 2010, and he was mining Bitcoins. And right now, if the identity of the guy was released, Satoshi Nakamoto will be richer than Facebook, Mark Zuckerberg. He'll be worth more than $50 billion, right? So unfortunately, those Bitcoins are still there in the blockchain, in the network, but nobody has the private keys. So this is an invention. I would say that blockchain was an invention created back in 2010. So what exactly is that? Blockchains are linked list that contains data, a hash pointer that points to a previous block. So think of it like a book. Okay, it's a book. We call it a ledger. Ledger has like thousands of pages, right? And if you look at a typical ledger, each page has a link to another page. So first page links to second page, third page, fourth page, fifth page. So bottom of each page, you will see a number there. Okay, 5 pointing to 6, 6 pointing to 7, 7 pointing to 8. That's it. That's all. Blockchain is that. Blockchain is a ledger with pages. So instead of having a page, is what we have is transactions. So instead of having a page number, what we have is a hash. So I'll go through all these things to make you understand. So if you already know what blockchain is, this might be like a kindergarten course for you. But if you don't have any idea what the blockchain is, this will be a PhD for you. So I'm not trying to insult your intelligence. I'm just trying to gauge where we are pitching this particular module. So this is what the blockchain looks like. So you have a block here. A block means, think of it as a ledger page, one single page, and here is another block, and so on. So you got like a millions of blocks, and each block is connected through a hash. So I'll talk about the hash in a minute. So why blockchain is so important is because if any data that gets into that block cannot be tampered with, cannot be changed, cannot be modified. Okay, so it is rock solid. It's a given evidence in any code of law, right? So this is why it's so popular to put your data on blockchain. Now remember this: blockchain is not here to replace your database. This is not a database, relational database program. It's never meant for that. So the blockchain is meant to put small amounts of data, such as how much money you have, what kind of loan that you're going to pay to a bank, small amount of information in blocks. That's it. It's not relational. One block doesn't link to multiple blocks. No primary key. There's no secondary key, and so on. So get this thing out of your mind. Blockchain is not a database. Blockchain is simply a ledger, like a Britannica. All right. So each block. Okay. Remember when I say block means imagine it's a page. Each block it contains this information. One is a block number, previous block hash, timestamp, mining difficulty, nonce, and a Merkle root hash. Right. So this consists of a typical block. And there are lots of blockchain protocols. Most of the blockchain protocols follows this format. Okay. So I have my personal blockchain, which is called the Jcoin, which has the official blockchain called Rosecoin. Okay, I'll show you those as well. All right, so this is what the blocks looks like. Block 0 linked to block 1, block 2, and what you see here is a fingerprint. It's called the hash. All right, to compute the hash, it's not that easy. It requires a huge amount of computing power. I'll show you the mathematics. I'll show you the calculation that goes behind it, and the reason for the Bitcoin value to be so high is this component called the fingerprint. All right. If it's easy to add a new block to the existing block, Bitcoin will not be so valuable because it's difficult. It's almost, it's not impossible. It takes huge computing resources to add a new block to the blockchain. All right. So when you zoom into a block, what does it look like? What does a block looks like? Okay. So this is a block 98, and you have a version info, version 1, version 7, version 6 of the protocol that's used. Then you have a nonce. Okay, the nonce is a very, very special number used only for this purpose, to compute the hash. Like compute the hash to link to the previous block. That's it. Then this is the hash of the previous block. Okay, so these two are related. Nonce is used to create the hash. Then you got the timestamp, which when the block was mined and added to the blockchain, and you have a Merkle root. I'll talk about the Merkle root next slide, which is pretty much it's a kind of a built-in security mechanism to secure the transaction that goes inside the block. All right, so you put a lot of transactions there, and you take a Merkle hash and store it over here, and take the whole hash whole block's hash. Do a computation so it's lower than the previous hash number. That's it. This is what it goes like. So this is the Genesis is the number. Genesis hash is called a 0 block. That means that's the first block in the blockchain. That means there is no previous block, right? So that's the first block that comes inside the network. And of course, you have a data, you got a hash, and you got a nonce, and so on. Okay, nonce is a small number. And a hash is which uses a 256 checksum of SHA hashing algorithm. All right, so why use blockchain? Why no government can control it? The reason being is the minute you create a blockchain, and anybody can attach themselves to it. Okay, so for example, we have blockchain in Rosecoin, and if you want a complete duplicate copy of the blockchain. We have almost like 25,000 entries. My personal blockchain has millions of entries. You can attach and get a copy of it, and you can participate in the ledger. So whatever whatever block gets added to a blockchain in Chile, if you are in Sydney, you also get an update. If you're in New York, you'll get an update. Okay, so the problem is you can't shut it down. For example, current Bitcoin blockchain has about 10,000 nodes all connected together, all have exact duplicate copy. So if you have money there in Bitcoin network, and if United States government decides, the federal department wants to shut down the Bitcoin because it's a threat to the national security because of people are using Bitcoin instead of US dollars for trading and transacting. That's a threat to the nation, right? So US dollar commands the whole world's attention. If there's whether you want to oil, whether you want to trade in stocks, whether you want to negotiate between countries. So US dollars is a powerful weapon. So the minute you remove US dollars, the country falls flat. So if Bitcoin takes over, US dollar doesn't make any, it loses its relevance. So you cannot shut it down because you have 10,000 nodes all over the world. I'll show you all these nodes in a while. So if you're going to shut it down, you got to shut down my node in my home, my office here. You got to shut down one in India, one in Australia, one in Pittsburgh, and Dubai. Oh my God, it's impossible. So that's the reason nobody owns the blockchain network. Nobody can control it. Nobody can. Here's the other part: regulate it. Okay, there's no regulation for blockchain. So this is almost a threat to government agencies, but not right now, because Bitcoin's value right now is about $500 billion. All right, so wait until it reaches $1 trillion in valuation, then it's time for trouble. Okay, so let's move on to advantages of blockchain. So why you want to use it? It's fault tolerance. Okay, it's a decentralized system. So for example, when a bank, so when you put $1 million in a Standard Chartered bank, and let's say Standard Chartered bank goes out of business, okay, and they get hacked, the CEO runs with the money, okay, some disaster strikes, your money goes along with it. Okay, there's no way that you can get your money from Standard Chartered. Don't worry, Standard Chartered will not go down. It's a very big organization. They have the branches all over the world, and they have fault tolerant systems and so on. So in blockchain, it's automatically fault tolerant. So you can't hack it. So what can you do? You're going to hack one node. The minute you hack one node, the other nodes will replace the hacked node immediately. Okay, that's what we call it's connected peer-to-peer, synchronized transactions. It's attack resistance, because if you're going to attack a blockchain, you better have the resource to attack about 10,000 of the nodes. And you have 10,000 nodes, you have millions of blocks there, and you want to mine those blocks. You know what? Just give up. Forget it. It won't happen. The only, if you ask me, the only agency that can do this massive attack they want to carry out, it's NSA or Google quantum computing, those kind of huge organizations. But then I don't think so. It's a small fish for them. It doesn't belong to Homeland Security. All right. So blockchain example. It's for commerce. Ethereum uses smart contracts. That eliminates lawyers. That eliminates banks. That eliminates middlemen. So I'll do some demos on that. But when it comes to holding values, Bitcoin blockchain, you can deposit money. You can deposit Bitcoins. You can buy Bitcoins. And you just wait until the value goes up. Simple as that. And right now, the Bitcoin value is it's not coming down. It's always on the rise. Then permissions. Okay. So what are permissions? Blockchain, most of the blockchain is public. Okay, most of the blockchain, anybody can see the transactions, anybody can see the data, anybody can see where the money went, which address it was sent to, and so on. So don't worry about encryption, because a blockchain is not based on encryption technology. Okay, the data is raw, it's plain. Okay, so blockchain is more based on hashing technologies. All right, so there is encryption when it comes to the RSA, primary key and public key for your Bitcoin address. But with the data itself, it's raw. You can use HTTP to just view it. Nobody cares. All right. So even the terrorists can see it. Even the government can see it. When you can see it, it's, as I said, open ledger. But the term called permissioned blockchain. So what does that mean? Okay, permission blockchain allows anyone to participate in them. Permissionless. That means it's open. So, for example, IBM has a smart ledger. Okay, so they use this blockchain to bring in suppliers and consumers together in a seamless network. For example, like you go to a supermarket and you pick up an apple. So you look at the apple and say, hey, this supermarket called Fridge Factory, and where does this apple come from? So right now you don't have any idea. So you got to go and ask the manager of the Fridge Factory, that the supermarket, hey, where did you buy your apple? The guy will say, let's say, he discloses data. He'll say, okay, all right, this apple comes from the supplier based in Brooklyn, all right, and it's called XYZ Vegetables. So you go to him and you ask him, hey, where did you get your apple? So he says, it's in Montana, in a small village, and I get my shipment from there. So you go to Montana and you ask the guys, where do you get this apple? So I pluck the apple from the ground. And where do you ship it to? And I package it and give it to FedEx. And you go to FedEx and where do you deliver it to? I deliver it to the local logistics center. You see how this so many players in the chain, right? What if you can streamline the activities in a blockchain, right? So yeah, you can do that. And that becomes a permission blockchain. That means it's not for the public. It's only for those vendors who participate in that logistics circle. Okay, that's permission. So IBM uses smart ledger. So you give permission to these players. Okay, that's not so popular. It's more like an enterprise database. I'll talk about that later. So cryptography, you got to master this. Okay, so if you want to master blockchain. So blockchain uses cryptography in a higher level of security. Okay, it's mostly on hashing. Typically, okay, what is a hash? A hash is a 64 characters long. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You start counting to 64. That's the character. Okay, so that doesn't change. It's the same for any data that you throw in it. So each block in the blockchain uses a 256-bit hash. That is a SHA-1 hash. It doesn't do one hash. It actually hashes multiple times. Okay, so the first data is a SHA-1 hash, and then it hashes that with base 58. Right, and so what is a hash? Let me show you here. Let me run it over here. So I'm going to hash this text. All right, so this is the number I get, okay, and that is 64 characters, regardless of whatever the data that I type in here. It will always give me 64 characters, and this number, it's unique in the entire galaxy. Trust me, guys, that you'll never find a duplicate number. That's how strong SHA-256 checksum is, the hashing is. The minute you find two numbers for the same number for two data, blockchain is dead. Encryption is dead. Internet is dead. I'm telling you, the banking transactions on the internet is also dead. So don't worry. It'll be always a unique number. All right. So it uses a SHA-256, not MD5 or CRC. So this is what a hashing is. You dump a file, you dump the entire Library of Congress data or entire government citizens data. It doesn't matter what you dump it. You'll always get 64 characters, digits, okay, unique value. All right. So the beauty is, if you change one single value, so for example, like Abracadabra gave me this, so I'm going to say Abracadabra, just add a space. It throws me an entirely new number here. But that's what tampering means. So once it's a hash, that's it. You can't tamper the data. The minute you tamper the data, you get a new value, and the gig is over. So the hash functions and in blockchain architecture, it's a heavily used. Okay, so like I said, to add a new block to the existing block, you need a hash with certain mathematical calculation. So I'll talk about the calculation in a minute. All right, so now you know what a blockchain is. It's block A, block C, block D is all connected together, and each block has a version number, Merkle tree, data, timestamp, and nonce and stuff. Now, Merkle tree, I didn't mention about what a Merkle tree is. Okay, so what is Merkle tree? Merkle tree is where it contains the data. Remember, block has a header and a data section, right? So the data section is designed in a typical format, okay, and that format is called Merkle tree. So how does that Merkle tree works? Okay, so here we go. All right, so what you do is, let's say you have data which shows you the list of top 10 movies you like. And actually, I just want to say Netflix, I was watching Air Force One by Harrison Ford. Oh my God. It's action movie to hell. I'm telling you, from start to end, I couldn't get up from the seat. It's so thrilling. Okay. So if you get a chance in the weekend, just go and watch Air Force One. It's still relevant today. All right. So you have top 10 movies, Air Force One, Rambo, and Indiana Jones, Back to the Future, blah, blah, blah. So what you do is you take the data and you divide it by 2. Okay. So I take the top data divided by 2, then you divide it by 2, divided by 2, and take this data divided by 2. That's what looks like a tree. But each branch of the tree has only 2 sub-leaves. All right. So when you divide the data, so what you do is you take the hash of these 2 leaves and you place it at the top. Then you take the hash of these 2 leaves and you place it at the top. And keep going layer after layer after layer after layer. All right, so why this is important? Because if you change the data over here, this hash changes. All the hashes changes in the Merkle tree, that's actually giveaway. Oh my God, the information is tampered with. So once you get the top and you add the top layers hash in the Merkle tree to the header. Okay, so that's what it is. All right, so why it is used, Merkle tree? To secure the data. So take a look at this slide. So what you have is a block 1 header, block 2, block 3. So this is the previous hash linked to the previous hash of the next hash. And this is linked to the next hash. And this is the Merkle roots hash. All right, so the data is over here. And all the transaction A, B, C, and D is divided into Merkle leaves, and the hashes are created. So once again, what is Merkle tree is used for? Very simple, to secure the data section so that you can't mess around with the transaction. The transaction is, hey, pay John $3,000 to this account. So you can't go and pay $3 to John. If you do that, you will know. I'll show you in a lab how that works. All right, so now you have a timestamp. Okay, so now look at the header. That's a block header, hash, timestamp, nonce, Merkle root hash, and the data. Okay, so that's the first block, the second block, third block, and so on. So if you expand the Merkle root, so you got the hash here, you got the hash in the leaf, and that's divided, and so on. So how many leaves are broken down depends on the data, the size. All right. So here is some slides which goes in depth on it. I'm going to skip this. So what is consensus? Okay, so this is a term that you need to understand. So in the context of blockchain, consensus means 2 or more parties must agree on the state of the data. So for example, anybody can connect to the Bitcoin network. Okay, so even you can do it if you have like 500 gigabit of hard disk space waiting, you can get an entire copy of the Bitcoin. So you will be like 10,001 user. All right. So what is consensus? Consensus means everybody, every node in the blockchain must have exactly the same data. Okay, so you can't have 1,000 transaction one node, another 3,000 transactions, another one is 500 transactions. No, it don't work. So how does the consensus, automate itself? Very, very simple. Simple formula. 10,000 nodes, and take a look at which of the node has the highest number of blocks. Okay, let's say the highest number of blocks is 1,200,007. Okay, the other nodes have like 3,000, 4,000. You know what they'll do? Those nodes will be wiped out with the highest nodes data. Okay, that's it. That's the consensus. All right. So, so the consensus also means mining. I'll talk about that. So there are different what do you call the formula to create the consensus: proof of work, proof of stake. Then you have a practical Byzantine fault tolerance used by IBM. So the most popular one is proof of work. Okay, Rocheston, we use this. Bitcoin uses this. Ethereum uses this. And the problem of proof of work is it is resource intensive. Okay, so it requires a lot of computing power, a lot of energy, a lot of electricity, and so on. So the industry is struggling to get rid of the proof of work to move to proof of stake. Okay, that doesn't require so much energy. Okay, you just trust few players to create the mining for you. All right, so right now Bitcoin uses this, Ethereum uses this. Ethereum is slowly moving to proof of stake. All right, now smart contracts. Okay, so I'm not a big fan of Bitcoin. I have no investments in Bitcoin, but I have investments in Ethereum. Right, because I love Ethereum, because I'm a programmer and I love smart contracts. So Bitcoin doesn't allow you to create contracts, Ethereum does. So what is smart contract? It's basically an application, a set of codes you embed it inside the Bitcoin, okay, and you execute it and transact between two parties. And digital signature, okay, you got to master this as well in blockchain. So what is digital signature is when you want to send money to somebody else, you got to say that, hey, I'm the guy who authorized this. How do you authorize that? It's using a private key. All right. So you take a data, use your private key, and create a digital signature. That's like a public key with your personal information, right? And then you put in the blockchain. That's it. So personal information is not your name and your city and so on blockchain. Personal information is basically your public key. That's it. Okay. So you got to understand how the digital signature works. All right. So when you look at the visualization of the blockchain, you got the magic number, block size, block header, transaction counter, and you got a reward, and you got an address. All right. So that is blockchain. Now, what is cryptocurrency? Cryptocurrency is just a protocol that uses blockchain as a platform, okay, to transact money. So let's keep it simple. It's a digital cash for the digital age. It's similar to regular money, but it's digital only. So pretty much give it like 20, 30 years until the government steps. If the government doesn't step in, cryptocurrency is the future. Okay, so you don't need euros, you don't need money, you don't need rupees, you don't need the currencies are all over the world. You just go and select one single currency. But the point is, Bitcoin is not the only currency. There are tons of currency: BTC Cash. Then you got Ethereum. Then you got ZSH, and of course, Rocheston have our own Rose coin. And I'll show you the values of each currency later. So how is cryptocurrency different from regular money? All right. So a cryptocurrency, nobody manages it. There's no central regulatory authority to tell what to do, what not to do. Simple as that. It's just network of computers running an open source code. The US dollar, the government issues that, government prints the money, and they distribute it based on the market demand. So how does it hold value? Okay, so Bitcoin holds its value by scarcity, all right? So if it is very difficult to get hold of Bitcoin, the value goes up. So that's the reason why gold is so valuable. You can't just dig up the earth to get gold, okay? So it takes a lot of pain to go to the gold mining rigs and pull it out and so on. So how is it secured? Okay, The protocol secures the blockchain, so the Bitcoin runs on the blockchain automatically secure. So other currencies like US dollars are secured by banks and governments. So banks have police to make sure that the printed paper is not tampered with and it's not a fake, and the banks ensure their own checks. Whether you do electronic transfer, you own the account, you have the balance, and you're not using them for terrorism and money laundering and so on. They do the checks. So in cryptocurrency, you can use for anything. Nobody cares, right? Nobody checks on you. Your name is not even attached to it. Nobody knows who you are. So are the physical bills or coins? Actually, no. There's nothing. It's all electronic, right? So if you lose the private key of your wallet, you're finished. So can I buy things with it? Absolutely, yes. For example, like Starbucks accepts Bitcoin. Okay, so Macy's in the US and PayPal, eBay accepts Bitcoin. All right, and so on. So Rocheston, we don't accept Bitcoins. Rocheston, we accept our own coin called Rose Coins. So if you want to buy the Rose Coin from third party, and if you want to pay for a course or certification, Rose Coins, we'll gladly take it, right? So that's the future. So as an organization, you have to move towards that, right? So either you participate in a public blockchain or you create your own blockchain. So the famous Bitcoin white paper is in dispute right now because Satoshi Nakamoto, okay, the invisible man who wrote the protocol, introduced back in 2008. He wrote a white paper, okay, which contains almost 9 pages. That's it. So if you're going to master blockchain, you better read this paper. You read in and out. So in this paper, doesn't talk about the word blockchain. So that's so funny because this guy invented blockchain. It talks about blocks, it talks about hashes, Merkle tree, it talks about the calculation of the mining, and so on. All right, so what he did is he published the white paper, put it on the forum, and in 2009 end, he released the program with the source code. This is in Rose. You can actually launch it and Windows XP can see the program right there. We put it for you. The source code is written in C++ and it's compiled for Windows XP platform. That was a platform that was widely used those days, 2009. All right. So if you look at the Bitcoin interface, it doesn't change that much, the wallet. Okay, it looks exactly like almost similar to the original Bitcoin wallet. Right. So this is the source code, all right? And it's open source. He released it under MIT license, Satoshi Nakamoto. So you take the source code and you modify it the way you like, and you create your own protocol. That's it. That's the reason why there are different variations of blockchains. In fact, we created our own blockchain based on original Bitcoin code, and we modified it, okay? And we released it back to the industry as a MIT license in GitHub. It's there. I'll show you when you get to that section. So if you want to study, if you're a programmer, how everything started, here you go. All right, so that's Bitcoin. So what are the different big cryptocurrencies available? You have a Bitcoin, Ethereum, Monero, Ripple, Litecoin, Dash, NEM, Stratus, Zcash, and so on. I mean, there are tons of, hundreds of them. And the difficulty of this the cryptocurrency is to maintain the blocks, maintain your computer, maintain your server, use a lot of energy for it, all right? And make sure your reputation is good. The organization that is running behind it, it's make sure they're open source and they're not for profit. So the Rose coin that we have, the minute I released it, you have a miners from Russia, miners from North Korea, miners from US, miners from Australia and Dubai. They're all participating in it because I lost control because the maximum that I mined was 45,000 Rose coins, and that's it. So today you have, so let me show you here. So you got tons of people mining. Look at that. So this is our Rose coin. And I have completely no control. There are about 1.2 million Rose coins in our blockchain, and it's even you can go and connect and you can start mining. All right. So how can the crypto make the world better? Okay. The point about cryptocurrency is it doesn't see you as you're black, you're white, you're rich, you're poor, you're wealthy, you're pauper, and you know what, you're from a poor nation, you're from a rich nation. It doesn't care. All right, since there's no identity, there is no influence on the cryptocurrency, anybody can participate, anybody can pay. So for example, imagine you want to open a bank account. Do you think it's easy? Go to give it a try. Okay, go to Chase and say, I want to open a bank account. First of all, they're going to ask you details. They're going to ask you your profile. They're going to investigate. You don't have terrorist links, and there's a lot of paperwork just to open a bank account and put $3,000. In blockchain, you don't need anything. Just download the wallet and then ask somebody to send you the money. You're back in business. All right. So this is a beautiful slide. It tells you how two people, different parts of the world, they can anonymously send and receive money using a cryptocurrency. So that makes farmers, that makes rickshaw guys, anybody can participate in the blockchain, the cryptocurrency network, unlike the banks. So how do they get the value? They get the value by, like I said, demand. So for example, the maximum coins that can be mined is 21 million for Bitcoin. Same thing for our Rose coin, same thing by Ethereum and so on. So you can mine more than that. All right. The governments can print any amount of paper bills, but Bitcoin, you cannot. That's the maximum. So since it's limited in supply, the value goes up. Okay. So in 2020, look at the 11,000. So today, the value is $35,000. Okay. It fluctuates. Goes 40, comes to 30, and so on. So that's the value it gets. Is it more valuable than gold? Right now, yes. If you have any gold bullion, sell your gold bullion, change it to Bitcoins. I'll guarantee you will go up. Okay. So it's not a whitewash. It's not a scam. It is real and it's climbing. In fact, PayPal it's buying in billions of dollars. Okay. They're getting into cryptocurrency. All right. So how does Bitcoin work? Who controls the Bitcoin? Nobody wants the network. It's a public ledger. And hey, is it anonymous? The question is, if I trade in Bitcoin, is it anonymous? Actually, no. I'll tell you why. Okay. So for example, if you look at our Rose coin here, okay. So here's a transaction. Somebody sent $99. It's not me, because I lost control of it. Somebody from this particular address sent it to this address. I have no idea who this guy is. Okay, and look at this amount of money he transferred from that account, and I have no idea. So what you do is, even though the information is open right here, what you can do is you can do a little bit of reconnaissance on the particular person and the particular Bitcoin address. So you can look at anybody in dark web is publishing the Bitcoin, anybody in the internet say send money to Bitcoin and so on. So you have to use lots of what do you call Sherlock Holmes tricks to find the address behind Bitcoin. So this one reason the US Secretary of Finance, Treasury Secretary, they want to bring a regulation such a way, if you want to send a Bitcoin to somebody else, you've got to reveal your ID. That's what banks do. Banks never let anyone to send anonymous money to a third party. Okay, you need to know each party's identity before you can send money. All right, so here is a very confusing part. What is mining? All right, okay. So you know very well, blockchain is blocks. One block connected to another block, another block. So each block has a hash which points the previous block. Okay, that's what it looks like, right? So what is mining? Mining is a process of validating other people's transactions on the computer, then aiding them in the long. So simply, Mining is a mathematical calculations you need to perform to create a hash value, okay, that connects to the previous hash. I'm going to repeat again. Mining is a simple mathematical calculation that you need to perform to link to the previous block. Now, what is that calculation? Okay, and why is it so difficult? Why it takes millions of computers to perform the mathematical calculation? Yeah, it is difficult. Okay, so let me show you. All right, so this is the mining math. All right, so Bitcoin protocol sets a target value. So what is a target value? So whenever a new block is created, a value is assigned by the protocol. Okay, the network, Bitcoin network assigns a value. Let's say the value is 3576, blah, blah, blah. So you take that value, run a mathematical calculation, and then you generate a number, okay, a hash, which is lower than that target value. That's it. Okay, target value is A, and you generate a number that lower than this. You know what? You can add it to the network. All right, so your target value will look something like this. Okay, so this number is given by the network, right? So that's what the target value is. All right, so mining is, so you had to find a number that's lower than this. So what is this? Remember I told you about a block has a header and data and so on. So you take the entire hash of the particular block that you're trying to mine and try to create a hash and check if this hash is lower than this. If not, add 1 to it. If not, add another 1 to the nonce and keep on counting. So let me show you a demo. All right, so what I'm going to do here is hold on. All right, I'm going to say echo let me look at this. Yeah, there you go. Echo minus n. Okay, and I'm going to add code SHA 256 sum. All right, now let's say the hello world here, what you see here, this hello world is the actual, the block's hash. Okay, the block has a header and date, timestamp, and all the stuff. That's a hash. So what you need to do is you need to find a hash. When you get the hash and you get a number, and you need to make sure that hash that you're generating is lower than the target value's hash. So this is not lower. So what you do is, this is a nonce comes in. So what is a nonce? You just add a 1 to the end of the hash of the block you're trying to create. Okay, is it lower? No. So keep going until you find the one that is lower, the previous one. When it's a lower, it's a number of zeros before the hash. I keep going, it's not many zeros before that. I don't have many zeros before that, and keep going until you find one. So here my nonce is 4250. That gives me number of zeros. Okay, before the hash 4250. Let me try that. Okay, wait, hold on. Yep, there you go. I didn't get number of zeros because my data was small w. There you go. You got 4 zeros here. But usually, when you add a nonce to the hash, you will get almost like 13 zeros in the front. So that's what mining is. Now I'm going to talk about advanced mining calculation. Because if you are trying to be an expert on blockchain, you better memorize this. Okay, how it works and so on. So just like cryptography, how you memorize RSA calculation, you got to memorize this as well if you want to be a blockchain professional. All right, so the target value, okay, here is it. The target value of a block is 538695. Okay, this is from the blocks field. So let me go and show you. Okay, what is the block? Okay, let me go and search that block. Okay, so here is the block Bitcoin. Go to the Bitcoin block. All right, so this is the Bitcoin block. So what you got is a header over here. You got a timestamp and height and blah blah blah, and you got a lot of transactions over here, right? And you got the Merkle tree of those transactions over here as well. All right, so you can go back to the previous block, you can go back to the next block, and so on. Now, what the network does is the network creates a value, and it stores here called the bits. This is it. All right. So when you try to create a new block, anybody can create a new block in the blockchain node. Take the pending transactions and add it, and then you create a hash. And if that particular block that you're going to add with a hash is lower than this number, then the entire network adds the new block. Now, here we go. Here's a calculation. So this particular number is actually this. When you do a mumbo jumbo Einstein genius calculation with all this stuff, you will get this number over here, which is 0, 0, blah, 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 and so on. Okay? All right. So this number, the mining, the difficulty or the bits number doesn't change until certain number of blocks has been mined. So it keeps changing. If you take more than 10 minutes to mine a block, it lowers the value. All right. So if you look at this is the target value. Look at the number of zeros: 1, 2, 3, 4, 5, 6, 7. So when you create a block and add it to the blockchain, you got to create a number lower than this, right? And if you look at the blocks hash, which is this is lower than this target number. That's it. That's mining. Simple as that, right? So take when you want to create a block, put the transactions together, and take the difficulty from the previous block from the network and calculate. Make sure your hash is lower than the previous hash. Ready to go. But if you look at the previous block, so let me go to 9.4. Now what you do is watch the difficulty 5.3, right? Still 5.3. You see that? All right. So the difficulty doesn't change unless the number of blocks that's mined or the value. So the time it takes to buy the new block is higher than 10 minutes. Okay, this is what the network does. You should be able to mine in 10 minutes. In Rosecoin, we program it for 2 minutes. All right. So there you go. That's the target value. And when you compute this, you will get sort of hashes, do a calculation. How do you do a calculation? Take a hash of that particular block, add a nonce. Nonce is increment, 1, 2, 3, 4, 5, 6. You add a nonce, calculate the checksum, and see if it's lower than that. All right, so that is the mining math. All right, cryptocurrency mining. Okay, this is not so easy. Okay, what miners are doing is competing with each other to solve a difficult cryptographic puzzle. All right, so that requires lots of resources, and these are the mining pools: and pool, Huobi, BTC, Signa, Poolin, and so on. So they pool the tons of users' computers, put them together to create that the hash or the mining block, and they share the profit to everybody. All right. So currently, a new block is mined. You get 6 bitcoins as a reward. All right. Now look at this. This is Bitforms. So they use Antmeter. That's a specialized GPU-powered devices, and they have like thousands in a farm. Okay, they're all computing the hash. Here is the mining pool. Oh my God, it's like a rack service of a Google Cloud storage. And this is interesting because it requires electricity and cooling, okay, and the power. Energy is huge to operate these kind of mining pools. So you have in China, you got the US, you got in right now in Iran. Iran is struggling to generate new revenue, so they're using electricity to do Bitcoin mining. And one example is this is a New York power plant. The New York power plant generates so much electricity, and it has excess every single day. Okay, so instead of storing the excess and throwing it away and giving it free to consumers, what they do is they power the excess electricity almost 106 megawatts. Okay, that can power almost 11,000 US homes into Bitcoin mining. And they generate, Jesus Christ, this was in 2020, 50,000 per day. Today, excuse me, today they generate $200,000 per day in Bitcoins. Remember, when new block is mined, you get 6 Bitcoins, right? One Bitcoin is worth about $40,000. You do the math. Jesus, man. This is amazing. And this is Poolin, another mining farm. It's huge. Here is the Bitcoin limits. So the Bitcoin, you can only mine about 21 million. Right now, there's in circulation is about 18 million. So I think by 2040, every Bitcoin will be exhausted. So that means the value is going to climb higher, higher, and higher. So the number of Bitcoin is one block is halved every 210,000 block. That means like the value of the mining value of a new block that's created is halved. So in 2009, it was 50 Bitcoins you get whenever you mine. In 2012, it was halved to 25, to 1612.5, and 2026.25. Next one is 2024. So that will be halved to 3 Bitcoins. All right. So only way to generate Bitcoins is generating a block and get rewarded. That's the only way. So here is an interesting site. The clock is ticking. And by 2024, it's going to halve again. So once again, the mining difficulty, I mentioned about the target and the value. You have to master this. You got to master the formula. You got to master how it works. And here is a beautiful diagram that shows the difficulty increases almost every single day. The more the difficulty, the higher the value of the Bitcoin. Okay. So mining. So what you can do is here is a simple simulation you can mine. Let me run this command. All right, so here we go. It doesn't really mine the Bitcoin, just simulating it, right? And looking at the hash and telling you whether it's lower than the previous, lower than the difficulty and so on. So it keeps running ever and ever and ever. Don't even bother. You can start the running program in the Bitcoin network, but you'll never succeed because you need massive computing power because difficulty is so high. So once it finds a number that is smaller than the target value, what happens is the node gets added to the blockchain and you would be rewarded 6 Bitcoins. So this is what a simulation looks like. All right, so let's move on. Okay, let's create a blockchain from scratch. All right, here is a code. It's written in Python, and see how that works and how you can modify it and so on. Okay, let's do this. Okay, now let me run it. Okay, just wait for it. It's going to take some time. All right, here we go. Got it. Okay, so this is the first block in the blockchain. All right, so this blockchain is very simple. It only contains previous hash and some transaction, say $1, something like that. Very simple. Okay, it doesn't have the timestamp, it doesn't have the date, and it doesn't have the Merkle tree and all that stuff. It's very simple. So I'm going to refresh again. I'm creating a third block over here, creating a fourth block, creating a fifth block. So now I want to see list all the blocks I created. I just go to chain, and here you go. So the data is in JSON format, right? So this is the block 1, this is the block 2, this is the block 3, and block 4. So you can see that each hash is linked to the previous hash, and so on. So what I did is I just created indisputable ledger blockchain. All right. So now if you want to add a transaction, okay, so what is a transaction? This is data. Okay, so usually it's money that you want transferred to somebody else. All right, so I'm going to go to add transaction. Okay, I need to modify the script, but I'll just do a dry run. All right, and you modify the script and you say you want to add $5 to somebody else, $6 to somebody else, and you know what? And you mine again, and you'll get a new block. All right, so I only had one node. So how do you create another node? So very simple. Open up another terminal and run in a different port, assuming that's a different computer, and link the two nodes together. And that's it. I'm doing manually. Yeah? Okay, usually Bitcoin, it's automatic. Wallet will do that for you. And you'll see a peer networks. So then you have to go and link the previous one and the previous one to the new node. And you will see all of them syncing the data. All right, this is from scratch. All right, using a Python, you can do it using Rose. All right, so next, let me show you visually how a blockchain works. Then we'll go to the sophisticated blockchain, the Bitcoin nodes. Go to the ledger. Here, do npm start. Okay, access 4,200. Just wait for the program to load. It takes some time to load. Come on, get it up. There you go. It's compiling. Yep, it's a wrong time doing the updates. Okay, got it. Okay, so this is it's a beautiful tool that visually shows you how the blocks are created in the chain. Okay, this is the Genesis block. This is the first block. So this is the second block, and you have a transactions over here. So what I'm going to do is I'm going to create a transaction. All right. So what is a transaction? It's usually an address and pay this money to this guy, and I sign with my private key, and I add it to the block. Right. So what happens is there are tons of transactions waiting in a queue. So you can pull all the transactions and make sure your block size doesn't exceed 1024 1 megabyte. Okay. And now you start mining it. So what you have to do is you got to find a value that's smaller than the previous hash. And we got it. Look at that. We mine this. Okay. Now create another transaction. I'm going to give money to this guy. 345, sign, and start mining. So there you go. That's my 4 transactions. So you can see the source code and you can create from scratch. This is what PayPal and JP Morgan does. All right. They take the open source and they modify and they add their own components to it. All right. So that's how you link. Look at this. This hash should link to this, and this, and so on. All right. So let's do another demo. All right. We finish this. We finish this. We finish this. Okay. Let's look at a typical block. How does the block looks like? So I'm going to start this program. I go to blocks and I run npm start. Okay, so once it runs, I just go to port 3000. All right, so let's take a look at the hash. So you know what the hash data is. So my Swiss bank account number is blah, blah, blah. Okay, there's your hash, right? So this is an example how hashes are created. All right, so this is a block. This is the first block. And what you usually see, this is the data, right? Remember the nonce I told you? Nonce is just a value you keep on adding until you find the hash that's lower than the previous hash. Okay, so once you find the nonce, you put it there. So what is the data? In Bitcoin, the data is input and input 34 from address to address, blah, blah, blah. Okay, so it's actually money. That's it, nothing else. It doesn't have anything other than from who you're sending money to who and how much. All right, so that's what a mining does. But when you create your own blockchain, this data can be anything. Even you can put your addresses there. All right, but the popular blockchains, they don't do that. And finally, look at that. It found the nonce. All right, so look at the blockchain. I got the first block over here. This is the second block. This is the third block, and so on. So you can keep on creating the blocks. That's what a typical block looks like. But Ethereum network, Ethereum also has money, which is called Ether, like Bitcoins. But more than that, you have smart contracts Ethereum blockchain. So instead of the data, you can have like a code. If X equals 1, then pay John $200. End of. While bank is still alive, and so on. So you just put your code. Okay, so they use a programming language called Solidity, okay, to run the code over there. And when a certain time or triggers and events, it fires up the execution. So I'll show you that in the Ethereum module. All right, so I'm going to mine this. The data means nothing over here. It just stores the data and adds it to, it mines and adds it to the blockchain. Now, why it's taking a so long time? Because it has to find the right nonce to get the number of zeros that's smaller than the previous one. Okay, look at this. It found the zeros. See, 1, 2, 3, 4, 5, 6 zeros, right? Okay, that takes a long time. All right, so here is the blocks added. You see this? This is linked to the previous hash, and so on, right? So I'm going to mine, put some data over here, and I'll mine this. And you'll find a hash, and that is lower than this, and you'll link it back to this one. It's taking some time. So let's wait. Imagine the real world. If you're doing a Bitcoin mining, just give up. I tried once to mine a Bitcoin. I pulled about 10 computers together. I was not even close. I was like 0.0001% of the mining capability. Okay, impossible unless you have a powerful mining rig. So here we go. So that's what the mining is. So if you change, why it is indisputable, if you change the data over here, put Haja over here, if you look at this. So this ledger, this block becomes irrelevant. This block, it becomes irrelevant. This block becomes irrelevant. So what you have to do is you got to mine this, you got to mine this, you got to mine this, and so on until all the hashes are in place. So that's why I said it's impossible to go and change the data in the blockchain. All right, so let's move on. Let's talk about distributed. So what is distributed? There's only one node in the blockchain. So remember I told you Bitcoin has about 10,000 nodes. So how do you create an additional node? Just click, here's a distributed. Okay, here is another copy of the entire blockchain. Here is another copy, here is another copy, and so on. So imagine 10,000 people have the exact copy. Okay, so if I change the data in this particular block, so all the other blocks needs to be mined. Now, this particular blockchain, it's messed up. This particular blockchain is messed up. This particular blockchain is messed up. Consensus will kick in and says, which blockchain has the largest, and that wins. So that particular blockchain will tell the PSC, hey, shut the hell up, revert it back, and synchronize with me. Okay, so that's how distributed blockchain works. All right, move on. Now talk about public key and private key. So I'm going to skip this. So if you know RSA algorithms, and generate a private key, and from the private key you can generate a public key. And with the private key you can sign a message. That means like only you send that data, you send that message. Nobody can spoof that. So here is a very interesting block in blockchain created by Satoshi Nakamoto called Genesis block. And you see that he was rewarded a Bitcoin value of $50, and the number of transactions was only one over here. All right, so Bitcoin node. Okay, so you want to participate in the Bitcoin. So what you can do? Okay, here we go. All you have to do is let me put a download directory. Okay, I'm going to run Bitcoin B. Okay, so I have installed the Bitcoin protocol here. All right, so what happened is it's connected to the Bitcoin node, and it's synchronizing all the blocks in the Bitcoin to my computer, my Rose here. All right, so it was 300 gigabyte then. Now it's almost like 500 gigabyte. Okay, so it takes about 4 to 5 days to synchronize the data. Probably if you don't have enough space, it'll fill up the entire hard disk. So you better do this with an external hard drive. Okay, so where is this data? Where is it synchronizing? See, synchronizing the block header. This is the block height. Okay, here is the data. Okay, it's in a hidden folder. All right, so there is your Bitcoin. So here is it. So this keeps increasing. Okay, that's your database, and these are the blocks. Okay, that's your index, and it'll increase. Just wait for it. Okay, and probably take about 500 gigabytes for this particular space. All right, I'm going to keep it running. I'll delete it later. Okay, it's still synchronizing. All right, then you have a wallet. Okay, it's called the Bitcoin wallet. So instead of synchronizing using the command line is better because I can see which blocks are being downloaded right now. So what you can do is you can run the Bitcoin node, the wallet. Sorry. Okay, so you see the interface is looks like the original Satoshi Nakamoto's interface, but this is the standard for all the blockchains. Okay, I'll show you my blockchain in a minute. We'll have the same interface. Now, as you can see, it's still synchronizing. Okay, and it's telling me it's going to take 12 years. No, it won't take 12 years. It's adjusting based on the bandwidth. It takes about 4 to 5 days to fully synchronize. And you can see over here, click on the help. Command line options, and you have this is the protocol's API. Okay, you can view the balance, you can view the wallet information, and you can send money. I can't send money right now because I'm still synchronizing. And here is the PS. You click on the PS, and it's trying to synchronize with all these PS around the world. So usually once it's finished, you'll see 10,000 nodes over here. Okay, so that's what this is. And the network traffic. All right, you can run some commands over here, and that gives you blockchain information of the node. So let me show you ours. CD here, desktop. is it? Hold on. Look at the progress, 0.1%. Okay, this is the Jcoin. If you look at this at the top, that's my personal blockchain, not Rocheston's. Rocheston is called Rosecoin. The interface is exactly the same. Okay, it's still synchronizing with global Jcoin network. All right, and you'll see the transaction over here. You can send money and you can receive money and so on. So I'm going to send $12 to my light sale. Click send. Wait for it. And there you go. It is sending, and it waits for a number of confirmations, new blocks. About 6 new blocks added after my mine block. Once that's done, I should be able to be confirmed for these transactions. So all right. So that's what the node is. I'm going to close this. All right. See, it's increasing. All right. So what you want to do is you want to delete these files. Okay, delete all these files except the Bitcoin conf. You're good to go. All right. So if you want to get rid of it, all right. So that's how you participate in the blockchain. All right. Download the wallet, start the wallet, or start the node, and you synchronize everything. So here's an example of the wallet, Bitcoin QT. I just showed you this. All right, and of course, it's CLI. So what is the Bitcoin CLI? It's a command line tool. So, for example, you could type any command based on the Bitcoin's API. So for example, what I'm doing is, you got to run the node first to run the command. So let me run over here. Okay, I'm going to run it over here in command options. There you go. I need to run the node to get this. All right, so what you get, you can type these CLI commands, and we have tons of CLI commands, but I'll show you an Ethereum module. That's a fun thing I like, okay? And it returns data in JSON format, and you can display this visually wherever you like, right? That's how it works. Okay, so we've done that. Let's move on. All right, and of course, if you want to get a block number in the CLI, you can actually type this command. It should give you the information about the particular block, height, version, and so on. So you can use a block explorer for that. All right, block explorer is a simple program which connects back to the network, retrieves the data in the JSON format, and gives you a beautiful GUI. But you can do it in a, what do you call it, is a command line mode if you want to. All right, so let's look at this. And this is the wallet information you can get from your wallet, how much money you have from the network. So the next thing is there are different wallets available for your Bitcoin. And here is a interesting wallet for Android or even iOS. But all these wallets are based on this Bitcoin QT, okay? The same, what they do is they use the same API, but to create it in a more graphical manner. Let me go to CD. And what command is that? Bitcoin.com. Okay. There you go. But my recommendation is to you is make sure you download the wallet from the source. Okay, don't load it from third parties. Don't download from somebody else from China and Australia and saying, hey, here is a wallet. They're trying to steal your private key. All right. And so here we go. So this is the Bitcoin wallet. So you need this wallet to send and receive money so that you can create your own wallet address. So all right, we finished this. Exporting a private key. This is important. Okay, so if you have $1 million in blockchain, Bitcoin, no. And if you lose the private key of your wallet, you're finished. Okay, unless you book your password is so simple, you can brute force and so on. But I'll show you the brute forcing part, how to hack that. But if your password is like 12 characters, impossible. There's a guy who had about $67 million and he lost the private key. He couldn't get hold of his Bitcoins. And he's crying like hell. He's telling people, hey, here is my wallet. If anybody can crack, I will give you half my money. Okay. So that was $67 million worth. Now today is like $200 million because of the increase in the Bitcoin price. He says, half is yours. So everybody was downloading his wallet and trying to crack, and they all gave up. I said, sorry, man, you can't do it. Okay. So if you lose your private key and you lose all your Bitcoins, assuming your password is weak. So here is a very interesting, a wallet is very colorful. It's not only trades Bitcoins, it trades Ethereum, Rose coins, and all the stuff. You can try that. It's called Exodus wallet. I love it. I love the user interface. Its GUI is absolutely gorgeous. I'm a GUI guy, okay? And interface is everything to me. All right, so how do you look up transactions? Of course, you need a blockchain explorer. So this is what you need. And let me show you here. And you just type in any number of the block you want, 345. And not only that, you can even type in the address. It'll give you how much money that was transferred back and forth. So what people do is they always generate new addresses for new transactions so that you can't trace it back. Okay, same address is being used to send 100 transactions. People are like, oh my God, this is linked to Haja. So if I use a different address to send different money to people, tracking is much more harder. Okay, this is the block explorer, right? So this is how can I look up a transaction? So go there and type in your number. So once again, as a developer, you have to master the APIs given by the protocol so that you can create your own interface, right? So there are different block explorers using different features. It all comes from the APIs. So how can I look up a transaction blockchain? Now look at this. This is the JSON format. If you do get block info. But this information is presented beautifully in GUI. That's what Block Explorer does. Okay. All right. So here is a SoChain, www.sochain.com. Here's a Block Explorer. The latest block is block 668. I'm going to click on this. Yeah. Control flag kicks in so that I'm not a bot trying to download all the data from them. Okay, I hate this. Whenever this pops up. This should be going in the background though. It shouldn't come in the front. It's a bad design. Okay, so let's move on while it's doing that. So how do you do your mining? All right, so you have to connect to a mining pool, create an account, and they'll give you username and password, okay, and start. So when you do that, if you find a hash and solve the problem, so you send it back to the mining pool. Mining pool, what they'll do is they will split the profit, the reward they get, 6 Bitcoins, among all the pool members. So if there are like 500,000 people connected to the pool and all trying to solve the problem, everybody gets a piece of the action. That's a good thing, right? So you buying the hardware, you get if you solve the problem, how much you get? Probably 50 cents or $1. That's it. So don't expect to get $40,000. No, the more people in the pool, it's the value goes lower. So anyway, this is a block. SoChain gave it to me, and these are the transactions in that block. A lot of transactions is going on over here. So this is the mining pool, which tells you what is the difficulty level, how much is being paid, and how many users are there. And this is what I'll be looking for: the port the mining pool uses for me to connect to. So you need to get a user account, and once you have that, go to the settings over here and paste it. Okay, so I have a username password Rocheston, and I'm mining. So will it be successful? Oh God, it's like I'm winning a lottery. Don't bother. Don't bother. Waste of time. Right. So here is a slush pool, which also does that. Allows you to make money. Now here, this is bitnodes.io, shows you all the nodes of Bitcoins. Okay, live. Let me show you bitnodes.io. So here is it's a live map. Okay, and they have almost let me see, 10,000 nodes. All right. So if you want to list on all the nodes, click on it. They'll give you a country, they'll give you an IP address, and they'll give you where they're located. All right. So running a Bitcoin node is not even stealth. It's not you're behind. It's not anonymous. They know who you are. Okay. The whole idea of blockchain is public. There's nothing hidden. Trust me. It's open book. Anybody can watch it. All right. So here we go. Here is a block. Here is a node. Okay, so this particular guy is connecting through the Tor network, running a Bitcoin. So what is a Bitcoin node? I just showed you. I just ran a Bitcoin node. Okay, that's it. You participate. So if I ran my Bitcoin node for a long time, I will actually appear here. I run this for a very long time, for 3-4 days or something. You'll see Haja here. Okay, what my computer name is and my address is. So if you want to actually check if you can still synchronize and if you participate, just put your IP address there and 833, check node, it'll appear. Okay, so you got a live map. So this live map tells you who is connecting to who's sending to which node, and who's mining the data. And you click on the blinking icon, you'll get more information on it. Okay, that's the live map. That's a BitNodes. We went through this. This is a BitNodes network map. How busy the entire network is. Okay, so let me show you. There you go. See that? Okay, just click on those dotted, colorful chart that appears. You'll see what's happening there. There you go. All right, so let me move on. It's busy. Okay, I love this. This particular site, what it does is it shows you where exactly a new block is mined, which part of the world. Okay, here we how many transactions being sent. There you go. This is amazing. I love to leave this running and looking at it for hours and hours and hours. So what you do is, if you have your office lobby or something, if you're a blockchain professional, and just display this on the television. Okay, you look so smart. Trust me. Every single Coinbase office has this on the chart in a big, huge television. All right. So is Binance. Okay, it's a nice, beautiful, colorful way of looking at it. All right. So Rocheston, we do have, of course, Rocheston is very active in the cyber currency, cryptocurrency space. All right. So we do have our own cyber scanner debt, cyber scanner, hold on, www cyber. Yeah, it's called Jericho. So we do have our, just don't know the password for that. Hold on. I think I got to go and redeem my password. All right, so you can sign up for a free account. Okay, so what you do is you will get this beautiful chart over here. Okay, it will give you a opportunity to buy and sell using third party. We don't actually have a platform to do the transactions, but you use a third party API like Binance and Coinbase. All right, and that's it. So you can see the value of the Bitcoins. And this is this is my favorite. This is an amazing blockchain explorer. The guy who created it is in Japan. Okay, so look at these all transactions, right? They're all being all waiting in a queue for somebody in the node to load up these transactions in a block and mine it and add it to the blockchain. So wait, they're still binding. 27 seconds ago, just wait for it. If somebody successfully creates a new block, there you go. One guy just did it. See it moved up. It's amazing. I'll click on this block. It tells you the hash is confirmed 10 seconds ago and so on. Here's the list of the transactions. All right. It's the same thing based on the API. Okay, it's much more colorful. And now, right now, this is absolutely the beautiful, the most stunning explorer, colorful explorer in the world. All right, this is for Ethereum, and I can just go for Bitcoin. And this is the Bitcoin transactions. All right, so let's move on. You can actually hold your private keys in Trezor. Okay, so one of the things you need to understand is Bitcoin cryptography. You've got to program this. Okay, you got to master this. So you got this encryption, RSA cryptography. You got what is that? ECC cryptography and so on. Similarly, there are APIs. There are commands that you need to understand to create the blockchain hashes and the keys. All right, the first one, let's do it. Okay, let me close the Bitcoin. All right, the first one is generate a random number using a ECC protocol. Okay, I'm going to do bx seed minus B256. All right, so what it does is it creates a unique hash. I can say that it's a unique number, 256 SHA-SUM number. All right, so we're going to use this to generate your Bitcoin address. So what I'm going to do is I'm going to run again, I'm going to run again, I'm going to run again. Every time you run again, you get a unique number. Okay, that's the first one. So the next is, okay, this. Let's create a private key from a random number. So how do you create a random number? I told you before. This is it. BXC minus B256, right? So now we're going to create a private key. Okay, don't worry. We're going to generate our address, Bitcoin address. So this is the command. All right, so there you go. It created a private key from a random number. It generated a random number. That this is the command C creates random number, and BXEC new generates the private key. All right, that's based on ECC cryptography, not RSA. All right, so with this command, what you need is we need to create a public key. So I need a public key. So I need a private key as an input. Got it. So that's my public key. So I got a pair. I got a private key and I got a public key. All right. So of course, in a Bitcoin and blockchain, they use your address is actually a 256 public key, but the number is 64 characters, right? So you need to go and hash that as well. So when you hash to base 58, you won't get so many digits. All right. So let's do that. So this command creates the address. on, let me do that. So why are we teaching you this? Because in our RCC class, we teach you programming. We expect you to program to create your own applications and platforms. This is what we do in Rocheston. We do ourselves. All right. So what I do is, that's my private key. So what I do is I pipe that over here, and bingo, this is my Bitcoin address. And that's it. So what is a Bitcoin address? Guys, it's nothing difficult. It just takes generate two keys, okay, private and public key. Make sure that private key is based on a very random number, okay, and then take that the private key and convert that to so not private key, public key. Take the public key, convert that to a hash, that to a base 58, and that's what you get, this number. And you see the number 1 here, that's very special. That's not part of your hash. This is a prefix for Bitcoin. So every cryptocurrency has a prefix. For example, Rocheston has a prefix called J, okay, and so on. I'll show you that in a minute. All right, so I finished this, and the next thing is how do you fetch a transaction? Okay, I'm trying to copy that. Okay. B, and here we go. And there you go. That's the transaction. Okay, so that's the input, and that's the output. That's a value. How much money you're sending it to who? All right. So there you go. We are converting this to the actual raw data, right? And this is what's stored in your blockchain. The blockchain doesn't store this actual value. This is converted to these digits, and we're converting these digits to data. This is it. Just a transaction. So now we're going to decode to actual text. Okay, so let's say this is part of the data in the blockchain network. I'm going to run this command. Always. Wait, did I get it correct? BX, blah, blah, blah. Decode. Yep, I think, okay, right. It should be one word, right? There shouldn't be any. All right, so I'm going to skip this. I made a mistake of concatenating it in my command over here. So I got to select this one. So you'll get your actual data. So this is the Genesis block of Bitcoin, block 0. And the data is converted to this. So what he did is in the Bitcoin Genesis block, he typed this as a first transaction, just the text. So if you want to look up a transaction, that's the command we need. And of course, we need to master this. BX help. What is it? Sorry, BX help. All right, so you got tons of commands over here. So this is called the Bitcoin cryptography, right? And you need to master this so that you can write new applications. So here we go. Now, how do you create Bitcoin URI? So what is a URI? URI has information about your name and what cost you want people to pay. So that's the URI. So you can send this link to somebody else. Okay, look at this label is Luke Jr. Message is donation 25 something and so on. All right, so that's HTTP URL, Bitcoin, blah, blah, blah. So when you click on it, it fires up your wallet. You can send the money to that particular guy. All right, so that's the URI. And if you get a URI and you want to decode what it is, remember this, the information is actually, it's coded. It's not in a readable format. So type this command. You should get information back called reverse coding, the cryptography. So there you go. It tells me the address is this, a label is gone, scheme is Bitcoin. All right. So you want to generate QR code. QR code is very popular. Take a picture of it. It takes you to the website for you to go and send money. So do a BX QR code minus P, the address. That's the address. And there you go. That's the QR code for that URI you get. So this is for signing messages. And this is for verifying a message in Bitcoin address. So, so that is Bitcoin. So it is a rocket science to create a cryptocurrency. Actually, yes. You need to know programming. You need to know development. You need to know C++. You need to have a lot of servers. And in fact, if you look at that, Rocheston is a open source Bitcoin. We released it almost like 6 months ago, last year, right? And I'll show you the valuation. It's pretty. We're not like $40,000 like a Bitcoin does, but we are pretty close to less than $1. That's okay. Bitcoin is almost 10 years. So this is the Rose coin. That's Rocheston's currency. So you can download the wallet. We have a wallet for just like Bitcoin does. For Mac OS, Windows, and Rosecoin, and Android, and whatnot. So we have instructions how to configure the wallet. So one of the things what you need to do, this is the block explorer I showed you. So the new block, that is mine, you'll see it over here. Okay, it's transparent. So next thing is when you create a blockchain, okay, so you have to publish the source code. Okay, you can't keep it proprietary because people will never use your blockchain because they have to see the code. There is no hanky-panky stuff there. The mining actually rewards you, and it's based on a standard protocol, and there's no bugs and so on. So I maintain it actually. I maintain this GitHub page, and here we go. So that's the Rose coin. So you can download it. It's and you can compile it. What you get is a wallet, all right? And you can start running the nodes on your network and so on. Okay. The next thing is what you got is the value. Let me show you the value. Okay, the market value for Rose coin. Here is the website for cryptocurrency. Okay, it's 0.1256. Bitcoin is trading about 33,000, and Ethereum is about 1,356. When I bought Ethereum, it was $400. So pretty much my investment is multiplied by 3 times. Like I said, I'm not a Bitcoin fan. I'm an Ethereum fan because I program smart contracts. All right, so this is the Rose coin that tells you the volatility. Okay, actually we are down over here. That's because of COVID-19. Okay, so people are very skeptical to invest in new cryptocurrencies. So they like to stick to Bitcoins. So if you look at the Bitcoin, look at that. If you look at the Bitcoin volatility, okay, it was a high that went to almost 40,000. Okay, now came back to $38,000. Okay, so that's the market value, and so here it should give me information about how much all of these guys are doing. Okay, and so on. So. Okay, that's the Rose coin. Let me skip this. And of course, we have a wallet over here. and you can start mining. Okay, we give instructions there. How do you mine your Rose coins and create it? Believe me, you can. It's not like Bitcoin. It's not that difficult. The difficulty level is very low. Now, you can create a vanity address. Usually, you don't want to do that because the whole idea of the Bitcoin address is privacy. Nobody should know who you are. Nobody should attach your name to it, your organization to it, why are you doing it, and so on. Anonymity is what makes cryptocurrency a platform everyone seeks. So if you don't want anonymity, you want to say, hey, you know what, I'm Haja, please send me money, I'm a donation, I'm for charity, then okay, you can get a vanity address. So let me show you how you do that. So Aditya, how am I doing with the time?
You have another half an hour to 40 minutes.
Good. I'm going to go to a vanity address. This is similar to what you see in generating vanity Bitcoin address. So what it does is it gives me I think it's capital L. Yeah, capital. It gives me a list of cryptocurrencies there. You can create a vanity. You got BTC, test, CIV. Let me take a look. I think Rosecoin should be here as well. Or there you go. Rocheston ZRC. It's called ZRC. Rocheston Rosecoin. All right. So let me generate a vanity address. So we'll run this command. Okay, I'm running a vanity address. I want the name to start with RCCE. So what it's trying to do is it's trying to brute force to find a public key, okay, that starts with RCCE. All right. So if it finds one, it'll just show you on the screen. Hey, I found a key that's unique in the network. So it's still going on. So once it finds, it'll show me here something like this on the slide. See, one RCCE, one something else on there. There you go. It found it. Okay, so that's. But don't try more than 4 characters. If you try like 6 and 10 characters, trust me, you had to brute force a lot. So you need a mining farm to create something like that. I think CAA has one. They did a CAA.com for onion address. So this is Haja. I'm trying to do my vanity for Rosecoin. So I get like ZRC. There you go. So how do you hack the wallet? Okay, so let me stop this. All right, here is a case study. Hackers are trying to break into this Bitcoin wallet holding about $690 million. Okay, Bitcoin. That was then. So now it's almost like more than $1.5 billion. Okay, this was when the Bitcoin was valued like $8,000, $9,000. Now it's like 40,000, right? So this guy lost the key, the wallet. So like I said, see, look at this. This is my Jcoin wallet. So much money I have in this wallet is almost $3 million. Not $3 million, 3 million Jcoins, right? So each Rose coin would be like a 0.10 cents. So that's almost like $40,000. So I have access to this because I have the key. Show you. I got that key over here to unlock this wallet. So if somebody goes and changes this, put a new password there, I'm screwed. Seriously. I will lose all this money. If this is my Bitcoin, I'm finished. So this is exactly what happened to this guy. Okay, he had about 690 million now. Now it's more than $1 million. He lost the key. So now he's saying, please, somebody could crack my wallet. I will share my money. All right, so how do you do this? How do you crack it? Okay, now we're going to use the RCC famous hashcat to do that. It's not automatic cracking. It's like a password brute forcing. So assuming your password is in one of the dictionaries, in German, Australian, or Webster dictionary, then work. Or you do brute forcing. Keep on doing it. So let's try it. So what I'm going to do is I'm going to the directory over here. Bitcoin. Hold on. Okay, and I run this command. So what you need is you need a wallet. The cryptocurrency is data stored in a wallet. And the wallet file is called wallet.dat. All right, all you need is this particular dat file. And what you're doing here is you're generating the Bitcoin to John. So what it does is it converts the Bitcoin private key, public key to brute force to a format for you to crack. All right, so I've done that. Here we go. So next thing is I need to run an algorithm. So let me do that. I need to save this to a file actually. I already did this. So I'm going to brute force. So I'm doing in memory, but if you have a hardware GPU, about 1,000 machines connected together, and it'll be faster. But poor guy, this guy, nobody could do it. Nobody could help him. Okay, it's people tried it and they said no way I can do it. Right? Let's see. I can crack it. It's initializing it. See that I'm not doing hardware interface. I'm being through memory. Okay, so let me do a full screen on this. Okay, so it's trying one word at a time. Okay, look at that. It's trying, hey, you know what? Your wallet password is password 1. Is it? No. Is your wallet password something this? No. So it keeps on trying. I mean, go forever until it finds one. But like I said, if your passphrase is very, very complex, good luck using a word list. All right. So there you go. It keeps on running it. You'll crack it eventually. Just wait for it. It's trying to guess what a secret is your password, Mickey is your password, summer is your password, is your password called internet, is your password called. I'm not doing a straight dictionary attack. But if I use uppercase, lowercase, special characters, and add numbers 1, 2, 3, 4, reverse it, and oh my God, you know what? That's really, really difficult. We'll just wait. It's still trying, it's still trying. Baseball. Password is Donald. His password is Holly. His password is hockey. His password is let me in. Okay, finally cracked it. Look at that. Okay, I did this. It's cracked. The password was called the Book of Genesis. That's a password. Okay. Oh my God. Finally, the guy can open up the $1 billion Bitcoins and he can go on a holiday. Right? He can start a political party, take on Donald Trump. There you go. So that's how you crack the wallet. This only works assuming you have a weak keys. Okay. So if you have a very powerful passphrase, then you need CPU mining machines. All right. So let me move on to Ethereum. Okay. So before I touch that, Aditya, can you just give me a 1 minute break? I'm going to get a cup of coffee and come back.
Sure, sir.
Thank you.
Yeah, just we'll take a quick break. Mr. Haja, I'll just get some coffee to refresh and come back.
Okay, guys, I'm back. Aditya, ready?
Yes, sir, we are ready. You can resume.
Okay, guys, thank you for joining. All right, so we finished the Bitcoin and we finished the cryptocurrency and all that stuff. Okay, so you have a rough idea how that works. If you want to have a hands-on practical, okay, you need to get a hold of Rocheston Rose. If you come for the RCC class, you get more than that. Okay, let's move on to Ethereum. This is my favorite platform. I love Ethereum. I love playing with this. I have investments in this, and because this is the Ethereum platform uses smart contracts. So, what is Ethereum? It's a cryptocurrency. It's based on blockchain, but unlike Bitcoin, the data for the Bitcoin that can only store is money. Send money from this account to that account. That's it. That's about it. Nothing else. Ethereum, the data section, right? You can put anything you want. You can put your name, you can put your address, you can put whatnot, and it's used to track ownership of digital currencies to run what we call decentralized applications. All right, the first thing you need to understand is Ether and gas. So, what is it? What is Ether? So, like I said, in Ethereum blockchain, it's just like Bitcoin, but they don't use BTC as the money, they use Ether as the money. All right, so another thing is called gas. So, what is gas in Ethereum? It's another word for Ether. That's it. It's a very fancy way. So, why you need gas? See, whenever you run transactions on Ethereum, you need to pay a transaction fee. Or the same thing with Bitcoin. When you send money from A to B address, you need to pay transaction fee. All right. But in Ethereum, you're not sending money from A to B. You're just sending a smart contract to be executed, and you're sending $0 actually, zero Ether. So in that case, you still have to pay transaction fee. So that transaction fee is called gas in Ethereum. Understand this. So I'll do some demo on this. You'll get an idea how that works. All right. So what is the Ethereum smart contract? Okay, smart contract is a code that runs on the Ethereum network based on certain conditions. Okay, that's it. If, for example, rent, let's say, you want to stay in my house and I'm not here, but I'll give you the key. You come from a post office, and I would say, please deposit $2,000 to the smart contract. All right. So you deposit $2,000 in Ether to the smart contract, and the smart contract has a condition. And I'm renting you my house for only 1 week. The minute you don't vacate after 1 week, send the $2,000 you deposited in your smart contract to your name. That's it. Okay. That means using smart contracts, you don't need lawyers, you don't need banks, you don't need middlemen. Okay. You don't need third parties. You can get rid of all these guys. That's the beauty of Ethereum. Okay. So as a blockchain expert or a cybersecurity expert, you have to know how this works. So how does Ethereum smart contract works? So for example, the biggest problem on the internet is buying something. Okay. So if you want to buy a product from a guy in or a girl in Japan, for example, you're in San Francisco, the girl is in Japan. So what you can do is, let me actually show you an example how that works. I think we have over here. Hold on. Okay, this is the slide I was talking about. I'll go back earlier and play with the ganache. All right, so this is the guy, Jason. He's in London, and here is a girl called Jessica in New York. She's a buyer, and he's a seller. So she wants to buy this dog over here, beautiful dog, and that is priced at Ether $1,200. So that's almost like $120,000 right now. So what happens is, so Jason asked, can you please send the money, $1,200 to me? Then I'll package and ship the dog in a FedEx and it'll arrive in a plane to you in Japan, sorry, in New York. London is, right? London to New York. So Jessica doesn't trust Jason. Jason doesn't trust Jessica. Okay, so if Jessica sends the money to Jason, what Jason sends a faulty dog. Or he doesn't even send the dog. Okay, or the dog is damaged. How can you ask him to replace one? All right. So if this is one-to-one, it's impossible to do transactions. So that's the reason why you go to what we call platforms like eBay, which is a middleman. So you send the money to eBay, and eBay connects with Jason. Jason sends the product to Jessica. If Jessica's happy, eBay releases the money. Okay, that's what we call as escrow. eBay acts as escrow here. All right, so what we do is, so before we go to play with smart contracts lab. Okay, so you got to understand something. Okay, ganache. So what is a ganache? Ganache is a Ethereum blockchain, but this is simulated in the memory. It's not connected to the real blockchain, so you can use for testing. All right, and so how do you? Ganache has two modes. So one is the command line mode. So I want to go to sudo ganache cli. So this is the client interface which runs in the command line. So there you go. So let me make my terminal bigger. You can see it. Okay, so what it does is it creates about 10 accounts and it creates the private keys for it. So you can have some Ether money, 100 Ether. This is useless. This is just for testing purposes, right? So what do you want? Okay, let me stop this. So what you want to do is you want a GUI version of the ganache. All right, so let me run that. Hold on. Now I know why I made it smaller, so I can see those commands. So I'm going to RCC directory, sudo Okay, Ganache loads. So what we have is we use Ethereum based on RCCE, which is persistent. Ganache is usually not persistent. So there is another option called keep the database on file. So all the transactions will be there. So we use this for class exercises. So Ganache is starting. Just wait for it. It's loading. Okay, so there you go. So these are the accounts, and it's all loaded up right here. Okay, that's the Ethereum in Ganache, which is a private. So we'll use a lot of labs based on this. Okay, so you need a MetaMask to interact with Ethereum. So what is a MetaMask? It's a plugin. So that means you need Chrome. All right, get a Chrome. And install the MetaMask. So I want to launch my browser. And my browser is here. Okay, so you will see, wait, hold on. Okay, here is MetaMask. Let me pin it over here. Okay, so you need this. Okay, so you will be interacting with the blockchain on Ethereum, Ganache, or even real main network in MetaMask. Now, of course, there is an app for your iOS and Android. So you can sync your app's MetaMask with this. So your money is still there. So I'll show you my real money in the MetaMask using my browser here. All right. So at the top, what you see is networks. Okay. So you want to connect to different networks. The first network is the main network. This is where the main money is, real money is. Then these are the test networks. They are useless money, only testing your smart contract whether works or not. Right? Here is a Cohen's test network, and Ringsby's a test network, Gourley's a test network, and so on. So what we're going to do is we're going to use our local host. Okay, and this connects with Ganache because Ganache listens on 8545. Oh God, what do I do? No, wait a minute. I closed the tab and that disappeared. Okay, so there you go. So this is connects with let me log on. Ganache. Okay, all right. So in the Ganache, I have lots of accounts, as you can see over here. Okay, and I have Jason, Peter, Vivaldi, and so on. Okay, so you can import your Ganache money over here because Ganache creates a test money, right? There's the test accounts. So what you do is if you go to Ganache, you will see a key over here, and take this private key, okay, for that account, and you paste it into MetaMask, and your account is loaded over there. All right, so there you go. Paste your private key, and you get the money. So, and my account is, let me show you my MetaMask account. All right, so this is okay. This is the main network. Okay, so I got almost $202 in the main network over here, and that's using MetaMask. And also we have a Rocheston Roma token, which is ERC20 token. I got $19 over here. So this is real money, right? And so what is my address? My address is this. So if I ask you to send money, I can ask you to send it to this address. All right, that's my real mainnet Ethereum address. I can say, can you please send me $100, and I will send you some practice exam questions, something like that. Okay, right? But this is good because it's anonymous. Nobody knows who you are. But you know what? I don't want anonymous. I'm a good guy. I don't want to hide behind the government or something. I'm not doing anything nasty. I'm doing a legal business, Rocheston. So what you can do is you can generate a custom address using a app.ens domains. I mean, this is a beautiful site which allows you to create one. For example, I'm going to say Haja. Is it available or not? Yeah, it's available. Haja.eth is available. Okay. So what you can do is you can buy this name. All right. It costs you money. Look at that. 1 year is going to cost me $163. Oh God, no way. That's the reason I didn't buy it. Okay. So if you want to buy this, just click register and fill in all the details. And this actually goes inside the blockchain. So you can ask somebody else, can you please send me money to haja.eth instead of saying send money to this address. You see what I'm saying? Okay. Most people then do that because they want to be anonymous. They do money laundering and stuff. All right, so let's move on to the next thing called Remix. So what is Remix? Okay, Remix is a platform to write smart contracts. Smart contracts is based on a language called Solidity, right? And I love the language because I'm a JavaScript programmer. So if you know JavaScript, you're right at home. You're ready to go. So you can write your code in your notepad and compile it and so on. But you know what? Ethereum has an online platform called Remix. Let me show you that. So this is the platform. Okay, it's an online platform. You don't install anything. It runs inside a browser beautifully. And this is where you can create smart contracts. Okay, and of course, you need to do something. You need to connect with MetaMask. Okay, without MetaMask, it won't work. All right, so that's the preferred platform for interacting with Ethereum. All right, so one thing you want to do is if you are programming using online Remix Solidity, okay, what you want to do is you want to click this injected Web3 over here. Let me go. Here is it. Injected Web3. And hold on. Sorry, what the hell I'm doing here? Sorry, guys. Yeah, no, why? I should be doing it inside my Rose. Yeah. Remix. The interface was funny. It's running in Safari. Because Safari doesn't support MetaMask. Only Chrome does. And Chrome and Firefox. Okay, let me get this up and running. What I miss? Org, sorry guys. Org. Org. Okay, so here we go. We got it. So I just got to go to link my MetaMask. There you go. Okay, there you go. It loads my account, and I can execute code over here, whatever I want, using a. Let me make this bigger. Using MetaMask. All right, so now we're ready for programming in Solidity. Okay, as long as you have enough money, but we have a lot of money with the Ganache, with the what simulated Ethereum network. Okay, so we also have a offline version of Remix. Okay, in a command line, so you can run it over here, so you don't need to click on the internet. And another Solidity compiler. It's called the Solidity IDE. We have one over here as well. All right, so let's see if we want to create a contract. Okay, so what is a contract? Contract is between two parties without using a middleman. All right, so let's imagine. Okay, Jessica wants to buy Jason that beautiful dog. And how does it two people communicate using Ethereum smart contract without eBay, without Amazon, or without any third party at all? No escrow, no banks, no lawyers, no contracts. We're using technology Ethereum. So first is step number one. Jessica wants to buy a limited edition dog from Jason. So she writes to Jason. She chats with WhatsApp. Jason asks about Jessica, and he gives the price. Hey, Jessica, the price is about 1,200 ethers. Are you okay? So Jessica says, yeah, I'm fine. So Jessica doesn't trust this guy. Jason doesn't trust Jessica. So both of them are strangers. They don't know each other. They haven't met each other. Okay. So Jason says, let me create a smart contract with Ethereum and we will purchase. We'll exchange merchandise. She says, okay, let's do it. So what Jason does is, Jason creates a contract with $1,200. Okay, let's say dollars. So it's from Ether, makes it better. So what Jason does is, he creates a address on the Ethereum network and deposits the $1,200. Why does Jason has to deposit $1,000? He's a seller, isn't it? Wait. I understand. There's a reason for it. So he deposits the money. So step 4, Jessica also deposits $1,200 in the pot. The pot is a contract. So the contract has about $2,400. All right. So both of them have to put that money in the contract. Okay, they've done it. So Jason ships the dog to Jessica. Okay, so Jessica receives step 6, the dog. And if the Jessica sees the dog is beautiful, no fault, there is nothing funny about it, it works as it is, it's fresh and new, there is no scratch, she releases the money in the contract to Jason. So next is the Jason's deposit also gets back to him. Okay, solves the problem. So now let's say Jessica, she sees the dog as defective. And she calls Jason, Jason, please send me another dog. Now, Jason can say, no, I don't want to send another dog. This is the one I have. If he says that, the $1,200 in the pot is still there. He can't get it unless Jessica releases the deposit to him. So Jason is forced to solve the problem and give the new dog to Jessica. You get what I'm saying? So there is no bank. There is no third party. Okay, let's execute this. All right, so my Ganache is running. And so I started my Ethereum, okay, remix. So I'm going to load a code, okay, from safe remote. Let me get it from here. I'll open it. And it should be an Ethereum safe remote purchase. Okay, that's the one. Right? So I make sure I want to see who I am connected to. Just want to make sure I'm Jason. All right. So Jason's one executing it. Okay, so there you go. I loaded this program over here. As you can see, these are the conditions. All right, now I'm going to compile it. Okay, so Solidity has different versions in development. So they keep on developing with new versions, new features. So if you have an old version and then when you run a new compiler, it may not work. It doesn't matter. So all you do is set your compiler to the right version. So here is 0.516. 0.516. Okay, so this code runs on this. And you see a tick here? That means compiled. All right. So what I'm going to do is I'm going to I'm in Jason's account to verify that. So I'm going to deposit 1,200 Ether. Okay, so let me do that. Drop down to Ether here. I'm going to execute the contract with 1,200 Ether. So I'm going to deploy it. Okay. So MetaMask kicks in. Say, hey, you want to deposit $1,200 to a contract address. And I said, okay. Now remember this, every contract or every transaction that you run on the node requires a gas. It's an Ether. It's just a transaction fee. I said, okay, fine, pay this money. Good to go. Okay, done. All right, so you will see the confirmation over here. You see this? These are the functions in the contract. So the contract is executed, contract address is this. This contract contains, okay, let me show you in Ganache. Okay, it says new contract is created. Look at this contract. Okay, so this is the contract. And see the text data over here? This is the actual code. Okay, it's a bytecode. You don't see the source code there. That's copyright protected by you because you wrote the code, right? So this code is actually this. It's compiled. Okay, it's compiled using the Solidity compiler over here. All right, so this contract contains 1,200. Okay, so how do you get this money out is based on certain conditions. Okay, fine. Now Jason has deposited this money. So now Jessica also has to deposit the money, isn't it? So this, you expand this, you get all the information over here. All right, now I'm going to switch back to Jessica in my account in MetaMask. Okay, Jessica's account is linked now. And okay, there is Jessica, select Jessica's account. All right, now I'm going to execute the contract buyer. So watch this. Okay, that's Jessica's account, and she deposits $1,200. But she clicks the icon called buyer. Okay, so these are the functions in the contract. I know you look primitive. You want a beautiful GUI from web application and all that. I'll show you that next. Okay, so understand this first, how raw you can create. I click buyer, confirmation. MetaMask kicks in with Jessica's account because I'm Jessica. But in real world, Jessica will be in some other country and she will do this. So I click confirm, paying the gas. Okay, so you'll see a transaction that Jessica made a contract call. And she deposited 1,200, and that's the gas was used. Look at that. That's value 1,200. All right. So now the pot contains $2,400. Okay. All right. So next is, what Jason ships the dog to Jessica, and Jessica receives the item. Okay. So what she's going to do is, Jessica is going to say, hey, you know what? I received the dog. And I'm going to click item received. See, $0 I'm paying the Ethereum, but still I had to pay gas. Whatever I call a transaction, I got to pay gas. I click confirm that. So done. So now Jason knows she released her money. Okay, she's done that. All right. So now what he had to do is, now there's a deposit that he paid, right? That also has to be released. So what happens is, I'm going to switch back to Jason's account. Now Jason can safely release his money. Let me switch back to JSON. That JSON's account. Okay, so I am in. Next is release. He clicks on this. Release seller. Okay, I'm going to pay the gas, confirm. Done. Now look at Jason's account. It changed to $9,009. Beautiful. Okay, so if the dog is damaged, he will never ever get the deposit back until Jessica says item received safely. You see what I'm saying? All right, so there's no lawyer, there's no dispute, there's nothing. Okay, so this is what a smart contract looks like. But you know what? The function over here, clicking over here in real life, you don't want to do this. You want something GUI. Okay, let's do a GUI version. So for that, what you need is dApps. Okay, so what is a dApp? Okay, dApp is called distributed applications. They're like normal apps and offer similar functions, but the key difference is they run peer-to-peer network on the blockchain. You run your code on the blockchain. Since the copy of that particular code is all over the world, so nobody can shut you down. Okay, there's no downtime, there's no censorship and whatnot. All right, so if you don't want to do this, clicking on these buttons over here and so on, you want a beautiful user interface, you need to master a plugin called Web3 Js. Okay, these are libraries, collection of libraries, allows you to interact with Ethereum node, whether Ganache or mainnet or Rixby or whatever it is in HTTP connections. And you can create powerful GUIs. Okay, beautiful applications. I'll show you the one we created. All right, so this is how it works. You've got a dApp front end, you've got an Ethereum node, and you have a smart contracts. So you want to run your smart contract, the Ethereum node, and the Ethereum node connects usually with the remix. We did this, right? No, this time we're going to use a HTML application using a Web3 library. All right, so let's start. The first example I'm going to show you is a lottery. So what is a lottery? Okay, 4 people get together, they throw money, and they spin a wheel, and it lands on a lucky winner, and he gets everything in the pot. Okay, now there are some rules for this smart contract. When the contract is deployed, the account holder becomes a manager. So Jason is going to deploy the contract. That means only he can spin the wheel to pick a winner, okay, randomly. So no other guys can pick a winner. All right, so we have a Ganache running in the background. So let's see this smart contract. All right, so what I'm going to do is I'm going to deploy the smart contract using Remix now. So let's do that. That is my name, Ethereum. Okay, all right. So let me run another application. You can deploy the command line. I'll show you that later as well. But let me run the lottery. There is a lottery contract. It's here. Nope, not that. Slide lottery.syl. Yep. All right, so this is a simple contract. Look at this. Like 12 lines. That's it. All right. So it picks a winner randomly, and you can deposit money to it. All right. So I think let's compile it. 0.422. Okay. So I'll make sure I'm using the right compiler. 422. Yep, it compiled 417. Sorry, there's a mistake. 417. You see a tick here. That's a tick. Okay, it compiled. It compiled correctly. Okay, so that is so that's done. Let me delete this. Okay, so I'm going to, I compiled it. Next is some JSON. Okay, and I'm going to deploy the contract. See, I'm not going to put any money now. Okay, I want other people to put money. I'm going to deploy the contract. Okay, 0, confirm. The contract is deployed. You will expand this. You will see it here, right here. Okay, enter, pick winner, get players, manage, whatever it is a contract. So what you need is you need a contract address. You need this one over here. Okay, because you need to add this to an application. All right, so we copy the contract address, and now let's go to the source code of Ethereum. See. Lottery, small case. All right, and I got to change the code in which file? I just want to check the file, lottery JS. Lottery JS over here. This is the contract address. All right, I save it. Okay, the contract is deployed in the network. Now I can access the contract using application. I can do that. I finish this. And let me start. Okay, let me open up a shell over here. And npm run start. It is starting. Okay, now I can access the contract using a GUI. So let me do that. Sorry, 3,000, not that, not that. I think it's updating the npm. Yeah, just wait for it, wait for it. There you go. All right, so this is it. This is the GUI you get, but you get a beautiful, sophisticated GUIs. I'll show you those latest in the smart contracts as well. Commercial companies, how they do it. Banks do it. Sorry, banks do not like blockchain, guys. You know, it's like a kryptonite for Superman, right? Same thing for banks. All right, so what I'm going to do is I'm going to enter the amount. I'm going to pay $200. Okay, enter. And okay, JSON. I'm going to put in the pot. Okay, so let me refresh it. You will see, there you go. You see one person entered the lottery and $200 in the pot. So let me choose another account. So this time I'm choosing Jessica, linking that to MetaMask. All right, so Jessica is adding $300 to the pot. Confirm. So refresh. I see two people, 500 in the pot. So I'm going to choose a third person, Peter. Okay, done. Peter is throwing 500. I'll show you more sophisticated application like voting. How can you use the blockchain for voting using smart contracts? All right, done. Now I want to pick a winner. All right. So the thing is, now Peter is connected, and Peter cannot pick a winner. You'll get an error there because a smart contract. There you go. It says only the person who can reject. Who created the contract can pick a winner. So I'm going to connect my MetaMask to JSON. Okay, now Jason, pick the winner. Okay, so there you go. Jason picked the winner, and Jessica Jessica gets the money. All right, so that's the smart contract. Okay, so this smart contract, nobody can cheat because the escrow account holds the money. All right, so the code is there. Now, commercial smart contracts. Okay, so you can write your smart contracts on your own, or you can buy from a marketplace. All right, so here is a marketplace which contains a lot of smart contracts you can purchase. Here is another one. Here is a crypto casino, which uses smart contracts. Airline uses smart contracts as well. So when you buy a flight ticket, and if your flight is delayed, usually you got to appeal to get your money back and so on. So this airline, what it does is, the minute you buy the insurance, $200 or $300 goes into the Ethereum pot, like a smart contract. So there is a condition that if the flight doesn't arrive on time or delayed, that particular insurance money will come to your account. I love this. You don't have to claim, you don't have to do anything. It's all automatic. There's a predictions, and there's a Golem smart contract. Okay, and here is a Ethereum. You can bet money on a game or something, just like lottery I told you, right? So this also has a similar one. And you got the Ethereum is widely used to play casino games. Okay, and when you win, the money comes back to you. This is a fortune check, bet chain, CryptoKitties. Okay, so CryptoKitties is really fun. Let me show you that. How much time I have, Aditya? Just want to make sure.
The next speaker is at 11 p.m. your time.
Okay, so I got like 45 minutes.
Let's say about 40 minutes. We'll need some time for the other speaker to come on as well.
That's a
introduction and all.
lot of time. I'll finish with it before that.
Okay.
CryptoKitties. Okay, so let me speak about CryptoKitties. The CryptoKitties was a craze in Japan. 3 years back, it clogged up the entire Ethereum network. Okay, so what it did is every 3 transactions out of 10 was CryptoKitties transaction Ethereum. Okay, and the Ethereum, the node and the network guys, they got together. CryptoKitties says, please slow down. Please stop selling massively of CryptoKitties, because we don't have the bandwidth on the Ethereum node, because we have thousands of transactions. Actually, Ethereum node processes about 400,000 transactions per day. Okay, so now CryptoKitties has slowed down. Request of Ethereum network. So what this is? Okay, let me show you what CryptoKitties is. It's nothing except you just get this picture. You pay money and you get a picture of a CryptoKitty. Okay, so this is a CryptoKitty that was sold for what, $140,000. I said, Jesus Christ, $140,000. One guy actually paid to get this particular image. That's it. Okay, this image is in the blockchain. So what is the image? It's just a number. The number is mapped to this image. All right. So let me show you mine. Hold on. So I do have an account. This is Jagiba account. This is my kitties. So here we go. So these are the kitties that I own. Okay, so one of my favorite kitties is this one. So let me see if I can buy a kitty live on the screen for you. So you know how this works, right? Okay, so what I'm going to do is, let me do a search. I'm going to buy a cheap kitty for this exercise. Okay, I won't pay $1,000 and all that. I pay $1, $2. All right, so here is a one, $5 and $6 and so on. Okay, so let me choose the next one. That's a 6, 6, 6. These are not good. All right, my God. The reason why it was $6 is because last time it was $400 Ethereum, right? Now Ethereum is like $1,200. That's why they hiked up all the prices. I'm just looking for a nice one. Jesus, everything is $6. Just give me a minute. I'm looking for a cute one. Not finding one. All right. I mean, the cutest ones cost you like almost like 300,000, 1 million. My goodness. All right. Let me take this guy. Okay. So as you can see, it's a $6. Okay, $6, 5 Ether. So let me buy this. So I do have MetaMask connected to the main network. There you go, Haja Ether. I have $200. So I want to spend $6. But even though it's $6, just look at the gas fee. The gas is pretty much high. Look at that, $19. Are you kidding me? To buy this, I got to pay $26. I said, forget it. Okay, it's I don't do that. And this is the transaction you get. Okay, the gas piece is extremely high in the network. I'm going to reject that. All right. So when you purchase, you'll get it on the network. So for example, look at my kitties. This is my favorite. A lot of people ask me to come on Haja, can you sell this? I said, no way. All right. I paid a lot of money for this. All right. So what you get is this number. That's the 192040. So that's in the blockchain. All right. So that's what this is. So you can actually buy and you can play with this whatever you want. That's CryptoKitty. Okay. So I talked about compiled code, right? So if you look at it, so this is a reverse engineer. Yeah, you can reverse engineer the bytecode, Solidity bytecode, but it won't be accurate, but it comes close. So this is the source code for the Solidity. So when it's reverse engineered, okay, this is the bytecode stored in the blockchain. Remember I told you about Bitcoin cryptography, how you can convert the bytecode to a text format. So this is what's stored over here. So when you reverse it, this is what you get. So that's what a transaction is stored in the blockchain. In Bitcoin, this is usually the address of sender and buyer of sending money. That's all. You won't get anything else. Rosecoin also, you won't get anything else. But for Ethereum, you can have code to execute. All right, so when does the code execute? Okay, when a new block is mined, and the miner who mines a block executes the code because he also gets the transaction fee, which is Ether. All right, so you don't execute it only once. If you want to execute the code again, then you create a new transaction and specify the contract. All right, so we move on. Then you got ERC token. So I'm going to skip this. What's ERC token? ERC token is basically creating your own blockchain, but instead of starting from scratch like what Rosecoin did, you can actually run it on an Ethereum platform. Okay, that's what Rosecoin is. So we have one called Roma token. Okay, so this is our ERC based token, and that's Ethereum. That's the value of the token. Okay, and when you create a ERC token, you have an address. Okay, so you can send this money to this address. It's like a normal contract. All right, you can send this money, you can receive this money, and so on. And when you create the ERC token, you can say how many coins you want in circulation, and what's the total supply, and so on. So if you look at Rocheston Exchange, let me show you a Roma token. So this is our Roma token value. Okay, it's valued $0.04. All right, so why you need to create ERC tokens? Okay, I'll tell you why in a minute. Okay, so look at the Explorer. Let's take a look at the Blockchain Explorer. So Roma token, Rocheston Roma token, to search. There you go. Rocheston Roma is here. And that's a contract address. All right. So you can buy and you can sell Roma tokens using this contract address. Now, why to create a token? Why you need this? All right. So you can get tokens as a discount or as an offer for companies. So instead of giving vouchers, you can say like, I'm going to give you like 300 Roma tokens, but you can redeem a product and paying the tokens back to us. So that's what you use. And actually, let me show you an example of how we use Roma tokens for gambling, all right, for Rocheston. A proof of concept, don't worry. We're not, violating any state or federal laws. All right, to create a token, what you need to do is we do have the script in Solidity. Run the script. And click deploy. And click that. Add the token and whatever you want. Click the name you want. And that's it. And you will get a token. All right, so follow that. So I'm finished. So to master Ethereum, you have to master Solidity programming. There are tons of tutorials. Just Google it. Solidity examples, Solidity for beginners. There are books on it. All right, just read about it and so on. So you need a platform to practice. Okay, the best platform I can think of is the world's best platform is Rocheston Reinvent, because we have everything lined up for education purposes. You don't install anything, you don't configure anything. The labs are there, the technology is there, and so on. It's almost like 500 gigabyte in size. Okay, whether you want quantum computing, whether you want virtualization, whether you want man-the-middle attack, it's already there. So Ethereum works by JSON calls. So these are the libraries. Okay, so where you make the JSON calls. Okay, Web3 and ETH accounts and run the smart contract, retrieve the value in the smart contract, and reverse engineer and so on. So Rocheston runs our own Ethereum node on our server. So we call it ether.rocheston.com. It's a full node of Ethereum. All right. And we have tons of RPC calls you can make. And this particular directory, it's, let me show you, where is it? I'm going to close this. Let me stop this. Okay, RPC calls. All right, so here we go. So this is all the RPC calls for you to practice, okay, but using our own node. So what you're getting is the best. It's not a compromised node or something. All right, so what we have is, so we have our own Ethereum block explorer running inside the Rose. So let me run that for you. Move that over here. Okay, here we go. I just want to say what port 8025. Okay. Okay, there you go. It's connected. Just wait for it. There you go. It's connected to our ether.rocheston.com, our one node. So let me search the latest node, latest block. Not the node, block is here. So these are the transactions in that particular block. You can see that. All right, these are the confirmations. You click on it. All these are small circles, means not many transactions. Big circles, you got a lot of transactions right here. It's GUI. It's fantastic. It works like magic. And there you go. That's it. So I'm going to stop that. Let me stop. Sorry. Okay, there you go. So Ethereum. That's a screenshot of that. All right. Now, Truffle. So what is Truffle? Truffle is a compiler. So instead of using Solidity on a remix on a web, you can program it using your own platform, okay, own development environment, interactive development environment. Okay, that's what Truffle is. So it's used for creating dApp applications. You can compile your Solidity code and you can migrate and push it to a Ethereum node, any node. That's a Ganache, mainnet, Risky, and CoveNet, and so on. So that's what this is. Okay, so one of the things what you need to understand is you need to configure your Truffle before you compile. The first thing is your code, which version does it compile on? Like I said, Solidity always keep moving forward. They don't wait for compatibility. So when you create a code, you got a specific version and you need to compile it in a specified version of the compiler. So you got to specify that. And this is where your network is. Okay, so you want to run a Rocheston on a main network and so on. All right, of course they run on a port and there are limits of gas. So you don't want to send a transaction, the gas is too much, like Cryptography did. Okay, $26 for gas is ridiculous. Seriously. All right, so you need to have a config file. So once you have a config file in a project, then you can start compiling. Okay, so we'll do that in a minute. Here's another example of a config file for Ganache. All right. So now what you do is you're going to use Truffle as exercise to build a voting app, and voting application. All right. So how does a voting application work? So the biggest problem in voting is tampering. All right. So if my name is Jason and I go and vote for Biden, and I don't want anybody else to use my name and vote. So what happens is when you vote for Biden, first thing is you need to have a key. Okay, you need to have a blockchain address. That's yours. That's identity. So when you vote, it's stored in a blockchain. If anybody else tries to vote with your identity, it gets rejected because it's already voted. So what the blockchain voting does is it secures from duplicating the votes, but it doesn't secure from identity. How do you know if Haja is the one, Jason is the one holding that key? That's a problem, right? So anyway, we'll try to solve that using the voting application using Truffle. So what I'm going to do is I'm going to I got too many codes over here. Okay, good. Okay, let me go to all right, so I'm here. So what I'm going to do is I got my code over here already compiled. Not compiled yet. It's SRC. You see the contracts over here? Let me show you. Okay, so here is a cat. That's selection contract in Solidity. You see that? Okay, it uses a particular version. So I had to configure in my config file for the version. So the code is right here. Okay, so I'm going to compile this. Remember, we used to use Remix, right? Now we don't have to. We can use Truffle. All right, so all I have to do is go to the directory and type compile. So let's see, if there's no errors, it should say compile successfully. All right, so it did compile. So next I move on. Migrate. Okay, it already compiled, there's no error there. All right, so I'm saying migrate means what it does is please push this contract to the network. So which network? I remember I told you about the settings. All right, so the settings has information about where you want to migrate to. So what I'm going to do is I'm going to run the command. You will see in Ganesh. You will see it right here. Okay, so there's your contract call, the new one over here. All right, so it made the contract. Everything's up to date. So next, what I'm going to do is okay, let me run the program. Okay, let me open up. I don't need Remix anymore because I'm using Truffle now. Leave. Okay, so it's loading. So I got two candidates over here, US presidential. One is Jason Springfield. Jessica, who want to vote to for selection? Of course, I'm going to vote for Jessica. Okay, all right, so I'm going to click vote. So what it's going to do is, let me see who I'm connected to. Jason, okay, fine. So I'm going to vote for Jessica using Jason's account. Okay, I'm going to pay the fee. Usually the government absorbs the fee. All right, there you go. Jessica receives one vote. All right, that's a transaction. So nobody can vote using my ID. So as long as you figure out a way to link this particular key to an identity like a face and your username and where you live and so on, you're pretty good. Okay, so you will see the transactions in the blockchain. Okay, so you'll see right over there. It's a contract call. Okay, so there you go. All right, so if I try to vote again, refresh, I can't. Look at that. It doesn't even appear. There's no option to select and click vote. I'm done. I'm done using blockchain. All right. And nobody can tamper with this. Nobody can say Haja voted for Jason anymore. All right. So there you go. So who's using blockchain? Nobody. Because people don't trust technology with voting. Voting is still paper ballot. Even the US and also counting is electronic. But when you want to vote, you have to take your chalk, you got to take a pencil, you got to tick. I vote for Jessica. All right, so let's build another one, just like CryptoKitties, but we built using pets. So we're going to sell some pets using this. Look at Truffle. So what we have is, we go to the pet shop. CD pet shop. And if you look at it, sorry. Right, so we have a code over here in the contracts. I'm going to compile it. So this is where it's going to get deployed. And that's the Solidity code. All right, now I'm going to run it. npm okay, visit 3000. I should get it. All right, now the thing is, I'm using it automatically loads to Firefox. I want to click Firefox because I need to run in Chrome, so that yeah, there you go. So let me make it bigger. Here is it. All right, just like CryptoKitties, right? So what we programmed is you can adopt a dog. Okay, so you can pay for it. All right, so what you get is you get this image. Because I want to adopt, I love this. I love this golden retriever. That's a name. That's what he calls Australian kiwi, right? Click it up. Your MetaMask kicks in, and I'm going to click confirm. So right now we didn't put a money there. You know what? You can actually modify script, say pay $30, $40, and so on. So that'll appear over here. Click confirm. Success, adapted. So you can modify it owned by JSON, whatever it is in the code. So the code is there in Rose, you can just play with it. Okay. So we can do all this because we know Solidity. We love Solidity so much. And that's how it's done. So next thing is, let's talk about a slot machine. Okay. So what you can do a slot machine is you pay money, and it should give you what it does is it should give you the money back. All right, so I'll show you a simple one. Then I'll show you our Rocheston's casino, like that as well. So let me go to 4288. 4288. The casino, we already compiled it for you. Okay, so we're just going to click play. So the casino has 595. Okay, so let me do a confirmation. Okay, increase the pot. All right, and it shows you the winner. So let me run again. I won actually. Confirm. Okay, and I won again. You won the 5th prize. All right, so that's the slot machine. You can actually try it. Here we go. This is the source code. You can view the source code and so on. All right. So this is you're gonna love this one. This is Rocheston's crypto casino. We built it ourselves from scratch. Okay, it's not a simple one. It's a very highly sophisticated commercial casino, which runs on a Ethereum node. So. Okay, this is the mainnet, runs on the mainnet as well. But instead of using money to bet, so what you need is, here we go, you got to log on with an account. So what you need is, you need Roma tokens. So that makes it legal for us. So who we sell it to and what we do and so on, okay? So here's a free spin. Actually, I won. I'll show you my amount there, and I can deposit the money back to my MetaMask. So the solitaires, sorry, the gambling, online gambling works. There are cheating going on because now it works using a technology called probably fair. All right. So what that means is, before you spin, there is a hash that the server created, and it creates a seed. So, for example, I'm going to say Haja is great. Right? So it's going to hash this, okay, and combine with this, and it's going to spin and to create a winner. And you can actually go and check whether my seed was used in the spin. Okay, so I'm going to show you that. I'm going to free spin. Actually, I won. It was not rigged. But if we go to history, and I'm going to click my game. Okay, so you will see verify. And there you go. That was a server secret, and that's a server hash, and my client seed is this. And oh my God, this is an accurate game. So I can go with Lucky Wheel. But if you want to check probably fair, this is it. If anyone, I won. If any gambling that does not use probably fair, that means, is not legal, is not valid, and there is cheating going on. Okay, so this is the blackjack. All right, so I'm going to show you. Stand. So let me lose. So I'm going to show you how do you deposit money. Okay, if you look at my account, deposit here. All right, it's in MetaMask. Okay, so if you want to deposit, so we only accept payment of Roma tokens, not ETH. So ETH is Roma tokens. And this is our address. This is address of gambling. So click proceed. All right. So how much I want to give? Okay. So I want to say, okay, look at that. Roma token kicks in. Okay. And I pay using that. And look at that. It's spinning, it's spinning, it's spinning because it's going to the network. Okay, there you go, 0.01. I'm sending the Roma token. It's trying to get a confirmation. And so that's the transaction into the real network. And I got to pay a transaction fee. That's $3 I'm paying, right, for 100 Roma tokens. So let me see the transaction here. Look at this. That's a transaction for our gambling. So it's still waiting for confirmation because it requires like 6 blocks to be mined, and finally it gets okay with me. So that's why the spinning wheel comes in. See, we call it unconfirmed. All right. So it keeps on waiting, 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 waiting. All right. So once it's done, you will get it. So I'll show you that in a minute. And I think we are done. I think I'm finished. Hyperledger is a blockchain by IBM. Okay, what is Hyperledger? It's not popular because you know what? The whole idea of blockchain is for the public, right? So this is a closed blockchain in which the buyer and supplier and the contractor, they all get together. Only they can create a smart contract. They can see the transaction. They can see the blocks and so on. Okay, so this is pretty much like for enterprises, right? So what you want to do this. So there you go. You see this particular circle over here? All of them participates in this transactions, and it's called permissioned blockchain. So you got application, run a query, and with the API calls, and get the results back. So you use for accounting, supply chains, finance, and medical records, education platforms, and so on. So my advice to you is, why use Hyperledger? Don't. If you're going to close it, use a database. Secure the database. Okay. So permissioned blockchain is nothing but a permissioned database, I call it. So if you want privacy, if you want to make sure that of course the Hyperledger doesn't have cryptocurrency at all. That's it. It's only used for smart contracts. You can send and receive money. It's tracking flow of what you call data in the nodes or logistics. All right. So the popular Hyperledger is called Sawtooth. It's open source, of course. The code is right there, but it's permission. You can make it permissionless, but don't do it. All right. So we have running in Brose. You can see it over here. And we don't have an Explorer, so you got to manually do a code. And the last is hacking blockchain. So okay, there you go. I finished this. You see this? Deposit is accepted and be reflected on your account as the transaction is confirmed. So if you see my account over here, okay, 100 Roma token is deposited. This is a real network. All right, you can just go and play it, guys. It's at if you go to Rocheston Casino, all right, so you can just play it right there. So this is this. Yeah, there you go. So we looked. We took a lot of time 3 months ago to create this beautiful, wonderful platform, Crypto Casino. You can just go and try it, create an account, and if you want a Roma token, okay, just ask Aditya. He'll send you 1,000 Roma tokens. Go ahead and play with it. Hacking blockchain. Let me move on that. There are a lot of techniques: Eclipse, Sybil, Selfish, mining. We're almost done, guys. There's me 5 minutes. I'm done. So this is will depend on X number of nodes selected to peer selection strategy to have its views. It didn't work in the initial stage. I don't think so. So mining malware. Okay, this is what is possible right now. Like if you have quantum computing power by Google or someone, and you have enough resources, and you can, if you take 51% of the nodes, let's say Bitcoin has about 10,000 nodes. If you control 5,001 of the nodes, that means you can create fake transactions. And all the other nodes will synchronize with you. That's it. Anybody who owns 51% of the nodes owns the blockchain. But that's impossible today. 10,000 nodes in different countries, I don't think so. Right? Unless you have a huge power. Remember this, when you have a 51%, you also have to mine every single block. Okay? Then you got time jag, you got Finney attack, race attack, and so on. So we have some presentations on blockchain. And that's about it, Aditya. I think we are done at the end. All right, so I'm done. So you can wrap it up.
Okay. Okay, sir. Thank you so much for that very in-depth presentation. I think everyone in the chats are very, very, very interested, and they do have a couple of questions, but we do have other speakers ready to go. So I'm going to have to bring them on for the panel discussion.
Okay. All right. Take care. Stay safe. Bye, guys. Love you.
Bye. 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 Bye.